to our friend. It's our pleasure to welcome you all for the second day DST Inspire Internship Science Camp. We are so delighted to have you with us. Once again, I welcome you all.
All our dreams can come true if we have the courage to pursue them. Now, I would like to call upon Ms. Aishwarya ma'am, Assistant Professor, Department of Physics, for Chief Guest introduction. I welcome you, ma'am.
Respected dignitaries on the dais and off the dais, faculty members, and my dear students, very good morning to one and all. It gives me great pleasure to introduce the chief guest, Dr. B.V.R. Tata sir, who has warmly accepted our invitation to join us today. Dr. B.V.R. Tata sir joined Gandhi Institute of Technology and Management University as a distinguished professor and received a prestigious Raja Ramana Fellowship from Department of Atomic Energy, and also working as Raja Ramana Fellowship at Gandhi Institute of Technology and Management University, Visakhapatnam campus. He was an outstanding scientist at Indira Gandhi Center for Atomic Research, Kalpakkam, India. He was a senior professor of Homi Bhabha National Institute. He was also head Condensed Matter Physics Division, Material Science Group at IGCAR, Kalpakkam. After superannuating from IGCAR in the year 2016, Dr. Tata sir joined as a visiting professor at Indian Institute of Technology, that is IIT, Palakkad, Kerala. In the year 2017, he was appointed as a full professor in the University of Hyderabad and established a computational soft condensed matter and photonics crystal lab at School of Physics, Hyderabad. Professor Tata superannuated from University of Hyderabad in the year 2021 and continued as an honorary professor at School of Physics, that is University of Hyderabad, till recently. Professor Tata sir is from 25th batch of Baba Atomic Research Center Training School and joined in Indira Gandhi Center for Atomic Research as scientific officer in the year 1982. He got his MSc Physics degree from Andhra University in 1977 and PhD degree from University of Madras in 1993. He has carried out postdoctoral studies at Central Laboratory, Osaka, Japan in 1996 to 1997 and Illinois Institute of Technology, Chicago, USA in 1998. Professor Tata has received several awards and honors. Prominent among them are awarded Raja Ramana Fellowship in September 2022, elected as Fellow of Telangana Academy of Sciences in 2020. Editorial Board Member of Journal of Physics, Pramana 2010 to 2022. Distinguished Faculty Award, Homi Bhabha National Institute in Mumbai 2015. Award of Erudite Visiting Professor, Mahatma Gandhi University, Kottayam, Kerala in 2011. Material Research Society of India Medal in 2009. Young Research Award in 1998. Kalpakkam Science and Technology Award in 1993. He has published 2 books and over 300 research papers in international journals and conferences, good number of citations. He has earned high reputation both nationally and internationally for the original, elegant and impressive experiments in the areas of phase transitions in nanoparticles dispersion and stimuli responsive nanogels, biocolloids, photonic crystals and computer simulations. His research interests are in the area of condensed matter, computer simulations and photonics, and Dr. Tata has delivered invited talks in several national and international conferences and at several prestigious research institutes and universities in India and abroad vice versa, that is Japan, Australia, USA, Mexico, Germany, Sweden, China and Singapore. Thank you for this opportunity. Thank you all.
Thank you, ma'am. Gifts are the currency of love. The more you give, the richer your heart becomes. Now, I request our principal, Dr. S. Manoharan sir, to present the memento for our resource person. I welcome you, sir.
Thank you, sir. Experience is a hard teacher because it gives the test first, the lesson afterward. It's my privilege to hand over the session to our resource person, Professor Dr. B.V.R. Tata, sir, Distinguished Professor and Rajaram Fellow, Head Center for Interdisciplinary Research, GITAM University, and Honorary Professor, University of Hyderabad, Andhra Pradesh. I welcome you, sir.
Okay, so let us start with good morning. Very good. So you see in my hand, good, yes, nice things, right? But you have to earn this thing when I ask some questions. Okay, those who answer correctly, they will get one chocolate from me. Okay, before we keep moving with respect to lecture, but as and when something I want to ask, I want to know what is your standard. Okay, accordingly I will fine tune my talk. Okay, because this is a topic which is for the research for the future. Okay, I hope some of you will become future researchers. The motivation for me to travel all the about 800 kilometers and come here is that one day probably one person will become like Abdul Kalam or Einstein or Newton. I want only physics people. That also is required if you are a Nobel Prize winner. So let us see how many are going to become Nobel Prize winners. Okay, it is not that my talk will be for chemists, my talk is for engineers, my talk is for physics people. Okay, but mainly oriented with respect to basics of the new materials. Okay, to control light. Okay, so the talk is going to be very light also. Okay, I don't want to make no equations, nothing. Okay, so let us now start with the talk, and you have to bear with me maximum of 90 minutes maximum. Okay, I have put exactly at 1 hour 20 minutes I have put an alarm so that I wind up whatever slides I have just to show the thing. So aim is not to bore with you. So it will be more interactive session, okay? And I will also show you some nice videos, okay, which you will see of what we can learn from nature, okay? Right. So the first and foremost is something to do with respect to title. What is that you are reading there? Please read. Very good. You know all people English, but I cannot give chocolate for that. Okay, now you know what is colors, you know, right? I could see this side is very colorful compared to this side, but there are some nice red t-shirts are there. Okay, yes sir? Say hello. Yes, for you also, because this title, if you see at the end of the title, you should put your collar high. I will tell you that why. Okay, right. So this is about colors we will talk about. Okay, but all these colors which you wear, I am going to talk a different color. Okay, so why that color? Okay, we know all this color, but I want to know first chocolate. When you know what is the origin of color, when you wear your red chunni or blue, green, where from this color is coming? One by one. First you have to raise the hand. I don't want it is not a political conference. Sir, one last minute. If you come here, please come this side so that you can keep because if she doesn't answer, somebody will get the chance. Please. Yeah, come. Tell me what is, why, for example, you wear a red shirt.
Red.
So why that red is coming?
Sir, by mingling many colors like white, primary colors we are mingling, sir.
No. I don't think they will only add red color only. They don't mingle so many colors. Then that shirt you will not buy. So that is not the answer. Mingling colors you will get white color. You see, RGB, red, green, blue. If you mingle, you will get white. For mixing different colors, you will get another color.
Sir,
but they don't add here.
Scattering of light.
Scattering of light is not going to give you red color. We can understand the blue color of the sky.
Sir, due to the reflection of the color, if I am wearing green color, the green color will be reflected, other colors will
But
be
why
absorbed.
first green is coming?
Sir,
See, we have light. If I take you to the pitch dark, you may wear nice red shirt. Can I see you as red shirt? Red chunni? In darkness. So it is something to do with light is falling on you. That is sunlight, right? In sunlight not only, I have purchased a new color. Unga chunni nalla irukku. Okay? So why that statement is because the white light. You are go in the darkness, you will not see that, right? So first thing is, white light should fall on you. Out of white light, only red chunni people will have red chunni, blue will be having blue. This color comes. So now you have to ask why your chunni is red or blue. It is something to do with you dress you wore. But incident thing is light. Incident thing is white light. White light we all know that it has 7 colors. Out of that, only one or couple of colors which you wear are reaching again to me. Okay, if I am seeing you. Why that color? No, but you don't, I don't see you say webcam. No, I see some blue here, some light yellow, greenish. No, that is not the answer. Still not getting the answer, right answer. Somebody has to tell. What gives you color on your dress? For example, you wore a maroon red. That maroon red is coming from where? You take cotton shirt, which is cotton is white, right? You can make it colored shirt, right? How do you make colored shirt? No, you don't use dispersion on the scale. On your shirt, are you using dispersion? No, no. We don't. Still, anybody please? First chocolate, who will get? Your red, any red t-shirt person. You people are what, 11th and 12th, right? 12th. Have you had pigments? For some people are fair complexion, some people will be dark in color. Okay. You use lipstick, some color. Why that is red color is coming? So what is mixed there? What is mixed in your shirt cloth or chunni cloth or on a lipstick? You have also different shades of lipstick. Pigments is one answer. Pigments are the materials which are put it in a certain material which is compatible to us and they put on your shirt. So if you take cotton, cotton is white, but you have to, there is one is pigment, second thing is a dye. This is a, I thought Coimbatore and Egmore is textile thing. So you never go. None of your parents doesn't do any textile. Anybody whose parents are textile, working in textile? Okay, none of you people. Only everybody is only, for example, even turmeric. Again, Erode is famous. Why turmeric is yellow? So there is a pigment there, okay, which is called curcumin, right? Curcumin, that's what is the molecule which is responsible for the yellow color, right? So now, so these colors, so I am just at colors. You say I have to go, I have to move around in my talk, okay? In this color, so this color is a consequence of, for example, if I take curcumin, okay, that has a molecule. The molecules will be at room temperature in the normal state. If you excite them with using light, okay, some molecules will go into the excited state, and in the excited state you will go to hilltop, you will be staying there, you will come back to ground state, same, these molecules also will come to ground state emitting that light. That light is what is your color. If you put a particular, if you put a lot of curcumin on your thing, you will get an yellow shirt. Okay. Whereas if you put a red pigment, yes. Red dye, yes. So dye molecules, pigment molecules, some of the natural molecules, they have excitation from a ground state to excited state in their vibrational states. Okay. And they come back. Why they go upstairs? Because you are shining light. So if there is no sunlight, nothing goes to excite. Okay? So when you shine light, white light on them, only the molecules, depending upon that energy is energy, you know, E is equal to h nu. How many of you know E is equal to h nu? All of you, I thought you will put. Okay? Because without that we cannot try. Energy is equal to Planck's constant times frequency. And frequency and wavelength are all related. What is the relationship between frequency and wavelength? Only one. First, sometime has nu is equal to C by lambda. We will give a chocolate for him. Is it okay? Okay, let's give at least first chocolate. So E is equal to h nu. And what is your name? Siva Surya. You want a more thing. I want more and more you have to learn. Okay. So energy is equal to h nu. And that nu is frequency. That frequency is related to the wavelength by nu is equal to C by lambda. What is C? Huh? Speed of light. Right. So we know. Fine. So we now learn what is the origin of the color. This color I always say because even in molecule you have a lot of electrons. These electrons ultimately go to higher exit state and come. So this is called, all colors which you wear are chemical colors because it's something to do with curcumin, pigment, dye. These are all chemical molecules. Okay. Even food dye. Some may be having all food you add, like carrot, beetroot, green. All these are all molecules, and colors come because of the molecular vibrations in that. Okay. But there is another way of producing colors. I'm not going to talk about. I'm a physics person, so I don't like that colors, but though I wear. Okay. Right. But I take physical color. I will tell you why physical colors are more important than chemical colors. So we are all now, you know, what is the origin of chemical color. We are now going to, next step is physical color. Okay. Before I go into that, so I will tell about that. Okay. Second thing is, so you should know, that is why structural color, the color comes due to a particular structure, nothing to do with vibrations. Okay. So some kind of structures if you make inside a molecule or a material and use that one, you will get nice color. That colors are going to be permanent, and so I am going to give you that type of colors. That's one. Okay. Second thing is, now you people all know. So electronics you people know. How many people know, sir, I use electronic devices. You have to give me 2 names for your electronic device which you use. Who will be first hand? 2 electronic devices. Yes. Tell me. Mobile phone she uses, which is an electronic device, but I will give you half chocolate only I should give. If iron box is an electrical device. It is not an electronic device, it is an electrical device. But still, okay. Computer, yes. But in this, you see, I want pure electronic device. Only electronics, nothing else. Whatever mobile, because you see, what is you see electrons. When you see your, who is your family actor? Vijay. So Vijay photo is coming because of electrons? No, you see his image is because of, again, light. Something to do with it. Today's talk is everything about light. Only electrons, only electronic device. But laptop also you will see lot of screens, videos, movies are able to. So it is not only electronics, there is something called photonics also, or optics. This is an electronic device. This is an electronic device because this is a digital watch, or even this is mechanical, what I see, but the hands are moving is because of the electronics, which is a quartz circuit. It is a quartz watch. Okay. So it is but radio, simple radio is an electronic device. Okay. There is nothing you see, only you listen songs. Okay. That is a electronic device. Right. Similar similarly some cameras, just cameras which olden days, cameras, they are all olden days. So they are electronic devices. Now, that electronic devices, what we said about mobile device or laptop and your TV screen, TVs, all this becomes optoelectronic devices. Because there is light also, your TV screen is a light, it is something to do with light, okay. Similarly, your mobile, all you scan, so you will see a lot of images, so it has to come again from light, okay. And without internet, nothing will work, right? Yes or no? Yes. Without internet, nothing works. Your life. First, you ask, unga kondati yaru illa, unga Wi-Fi password enna? So Wi-Fi is coming from again internet. So this is again where I said about Wi-Fi is electromagnetic waves. So you people should use, how many people know electromagnetic waves? Somebody has to raise the hand. Sir, I know about electromagnetic wave. Yes. Tell me, what do you know about electromagnetic wave? Okay. How is it different from sound waves? No, sound waves are longitudinal waves. Light waves are transverse waves, I agree. So I will give you a chocolate. Any other property of light? Light waves. Light is an electromagnetic wave, right? No medium is required, yes. So you deserve definitely a chocolate. And they all move with. So light is an electromagnetic wave, exactly, and it has electric and magnetic fields, not electric and magnetic fields, hence it is called electric magnetic. I will show you the picture. And it moves with velocity of light, which is 3 into meters per second, right? So that much also we learned. So we learned about light, and it is an electromagnetic wave, right? And it's electric magnetic thing. It is a transverse wave, unlike sound waves. It doesn't require a medium. These are the good properties of light or electromagnetic waves. Other than light, now another chocolate. Other than light, which are the other electromagnetic waves you know? Anything you can talk about. Okay? Gamma rays, who said? Yes, you deserve one. Next. Ultraviolet, yes. Yes. X-rays. So 3 of you should come and take chocolates. So X-rays. So first gamma rays. Who is taking gamma rays? Because gamma rays also, which are the highest frequency, which come from nucleus, radioactive materials. Okay? So gamma rays are having energy or frequency more than visible rays. That's why if gamma rays goes inside, your DNA will get cut, and if you are exposure more, you will get cancer. Of course, you can also treat the cancer using gamma rays. Okay? You can, more exposure, you will get cancer. If you control the exposure of gamma rays, you will get cancer treatment, because you can kill the cancer cells. So gamma rays are very, very important, and though their energy is very high, they travel with, will they travel with faster or slower or same? Same, yes. So whether X-rays or light or gamma rays or ultraviolet rays, all travel with velocity of light in only in free space or air. Okay? Only in vacuum or free space or air, you will, all these waves will travel, which are electromagnetic waves, they all travel with the velocity of light. Okay? You have to take. So X-rays we use. X-rays, without X-rays. For example, your eye can only see visible light. If it can see X-rays also, then what will you like? You will never marry any guy. Because everybody will look like pay. Right? Only skeletons are. So, if Fortunately, God has not given a detector which is not seeing X-rays. So X-ray, fortunately, we don't have X-ray eyes. We don't have IR eyes also, infrared. Dogs, bats, all this. Night there are many animals. When we sleep, they will work. Get rid of all these human beings. They are going to sleep. Now they are the kingdom. So night kingdom is by certain animals. Okay? They all can see infrared waves because that time there is no visible light. So infrared also is electromagnetic wave. They also travel with light. So whenever heat is there, heat is in infrared wave. So they sense the heat, they can sense the heat. We have a heat sensor. Your eye cannot sense heat, but your skin can sense. So this is one sensor. This is one sensor. This is sound sensor. Okay? So we are having so many sensors. This has a chemical sensor, tongue. Okay? So we have built with so many sensors for sensing different waves and different type of waves. Okay? Now, we'll come back again to the talk. So when we talk about light, I'm going to talk only in the visible range. Somebody will get chocolate now if they tell what is visible range, either wavelength or frequency. Somebody has to raise hand and then tell. 25 centimeters. That is your scale. What is the wavelength of visible range? 400
to 700 nanometers.
Nanometers. Correct. Exactly. 400 to 700 nanometers is exactly. That is what your eye can see also. And out of the total electromagnetic spectrum, we can only sense very small. You cannot see X-rays. But X-rays, if you want to see, you have to convert them into visible. So you use materials, either your photographic plate or X-ray plate, etc. Convert X-rays to visible rays, and then you see. So the image is recorded in X-rays, but what you see, white bones or anything, is because you convert the X-rays into visible light image, then you can see. So everything what we do, we use always whatever is not seen, whatever we cannot see, because third eye, all of us have third eye. We thought only Ishvara has. If you think you have only Ishvara has third eye, no. We all have third eye, which is the brain. Brain can see many things. Right? Brain can see Mars. That's how you are sending a vehicle to Mars. Other day we landed on moon. Right? We communicated with the moon. This is all because of not with our eyes or anything. We use the infrared waves, radio waves, all these things. But those devices we use through intelligence. That's where the science and technology comes. Right? So without that, that's where we use the electromagnetic spectrum everywhere. Without electromagnetic spectrum, we cannot. If sun is not there, actually last 7-8 days in Visakhapatnam there is no sun because of cloudy. I got vexed with wet. Okay, I'm Erode, I'm enjoying, and a lot of wetness also is coming on my skin because of heat. Okay, so the sun, without sun, we do. That is the source of energy for us. Okay, and it emits all electromagnetic waves, gamma rays, X-rays, cosmic rays. Highest is cosmic rays, then gamma rays, then X-rays, then ultraviolet, then visible, then infrared, then microwaves. Then microwaves, all of you will be using at your home, right? You have a microwave oven, right? Then radio waves, which we use, radios, and all your FM radio, etc. Then comes millimeter waves. But all this entire spectrum is electromagnetic waves. They all travel with velocity of light, which is 3 into 10 power 8 meters per second, which is the highest speed. Neither you nor me can reach that height. Right? None of you can go with speed more than the velocity of light. Yes? Why? If I ask you that question, why none of us or any material or any particle, electron, neutron, proton, you talk about anything, or none of them can go more than speed of Light. Who will be giving me answer? He is.
Because light has no mass.
Light has no mass. Fantastic answer. Light has no mass. So, if you want to, like, why we, sir, today I am jogging because you want to shed some weight so that you can run. If you are 280 kilos, sir, I am unable to walk. Right? So, if you have to gain momentum or more velocity, you have to shed your weight. So, photons, forget it. No more mass for me. Hence, it can reach highest velocity. Right? So, he gained another chocolate. Fantastic answer. So, those massless particles are called photons. So, all electromagnetic waves, the quantum particle of electromagnetic waves is called photon. Okay? Photon. And photons are quantum particles. Okay? Simplest example, we all know sound also has a photon particles which we call phonons. Okay? Let's not deviate too much because science is so much ocean. I can keep jumping here and there, but let's come. So photons are quantum particles of light. But initially you people might have studied light in your 6th class. Light goes in linear path, rectilinear propagation of light. But today, light, no, it also can bend. Can also do all sorts of things. Okay? Only as a ray it can go. But if you go eliminate, thin it, then you will get waves, and if you still go into quantum mechanical way, it will have particles. First Newton said light is particles. Because he is a man, Newton is always dealt with particles. And all your Newton's laws of motion are for particles which have mass. But then he could not eat sambar because there is a dal there. But because he also thought light has particles which have mass. So Newton also can do wrong. Right? But then it is Einstein who said it is waves but it has particles. Those particles are called photons and photoelectric effect. How many people know photoelectric effect? Next question. Yes, photoelectric effect. Quickly tell what is photoelectric effect. Electron will be cool down and answer.
So the electron will be deviating from the metal plate which the energy is striking.
No. Anybody else? Photoelectric effect. Einstein got Nobel Prize for that. Actually, he is a theoretician. He did actually relativity, E is equal to mc square, all this. But he got Nobel Prize to explain photoelectric effect using the concept of photon. Okay? And if photons, that is light, falls, so if nobody tells, I will tell. And I will take chocolate. Is it okay? So, when light falls, take visible light itself, okay? We can take these photons, you take like sodium, potassium, these are metals, including gold, for example. You can take these metals and shine these photons, which are nothing but light. Then, these photons have energy, because the E is equal to h nu, right? H nu is photon, which has a certain energy. If this particle goes and hits inside the material, in material what has? Electrons. Metals have so many electrons. So, when this energy goes and hits that electron, in a lot of stones, or you can put and take another stone and hit, and all the stones inside will come. This is one game which we used to play in my childhood, right? So same way, with a bigger stone, you can hit smaller stones, and some stone will come out of that circle, right? Some now in the circle is metal, so there are electrons which are your particles. Photon is also a particle. This particle will go, because it's an energetic particle, this will go and hit, and the electron will come out. Whatever is there, but electrons are bound to the metal, right? So to knock off, certain energy is required. Similarly, a stone to throw out, because it is stuck to the surface because of the gravity. So there is a gravitational energy. So you have to take a stone, you have to give a kinetic energy. With that, if it hits, the stone will come out. Similarly, a photon with an energy, if you shine that and the photon knocks off the electron, that electron, it transfers extra energy, first knocking off that energy, and then remaining energy with that which the electron will come out. Not deviation. So, hello madam, not deviation, electron coming out. Okay, so you can use light can be converted into electrons with certain energy. So he has taken h nu energy and some work function W naught, he said, remaining half mv square, which is the electron with its kinetic energy. So this equation is photoelectric equation, effect equation. Okay, so now, so we know how to convert photons into electrons with certain energy, right? So now, having said all this, now I need to come to my talk. Okay, let's move on to next thing. So I gave reasonably good introduction. Sir is not moving. Somebody can move the thing. Appears to be. Okay. So I'm just going to talk about light. We all know what you people have studied so far, some aspects, but I will give you a little bit better way, and then come to the word called, we all live in the electronics and optoelectronics. We came up to a stage. My childhood, only electronics. Actually, I don't have even electronics. When I was reading at your +2, I was only using normal light, candle light, and doing it, no radio, nothing. But some places radios are there. So I used to go for cricket commentary, only listening, no seeing TV watches, only listening TV commentary, because only through radio. So it's a pure electronic device. Okay. So that's what is my childhood as when I'm doing up to MSc. Okay. So those are electronics. Now I'm vexed with electronics because I want to do things faster. Right? Are you unhappy with electronics or not? Even optoelectronics. When do you unhappy when you use your mobile? Tell me. I want this answer. No chocolate, but I want to tell. When do you are unhappy when you use mobile? Battery is full. I will give you a mobile with full battery. What is that hanging out? What is that hanging out? Let's say your friend has shared with you the birthday picture and you want to download. No. Okay, these are all unhappiness, but I am looking for an answer where you get stuck in download. You are unable to download a picture, right? So, slow internet, but internet is not really slow. It is the electrons which are working in the internet, they are slow. Okay? I will tell you. Okay? So, electronics, many things. You people also told about heat, right? Your laptop and mobile also gets heated. It's all because still electrons are working. The negative aspects of electrons is Iron box we want. Okay? But all your mobile devices, computers, TVs, they should not get heated. Actually, we changed the bulb from to LED because out of so much current we put, we will get only light, very small. Remaining is a heat. When you touch the bulb, you have to apply Barnal ointment, right? Because heat is generated, which is not good, right? So we don't want heat. The heat is coming because of electrons, right? Because electrons have to work, they have to get heat. Light speed, what will be an electron in a material in electron circuit? What is the typical speed with which electrons can move? If you take an electronic circuit, okay, when you do a switch, bulb goes. But what is the electrons from here to gone there through electric wire? Okay, when you put the switch up, because you close the circuit. So electrons have traveled. Of course, the electron here, it doesn't go to up to the bulb, but it sends other light. It's through a conduction process, which is called electrical conduction. Now, but what is the typical speed? Typical speed with which electrons move in an electronic circuit. We know 10 power 8 meters per second is light. And electrons have mass, so they cannot go there. So it has to be slower. How much is that slower? Some guess, intelligent guess also will get one chocolate. How much? We know 10 power 8 meters per second is the thing. And how much if you electrons can compete? Wait, tell me. No, speed doesn't depend upon the distance. Nothing to do with resistance. I'm looking for speed. Speed எவ்வளவு சொல்லு? No, then it has to be massless. Electrons have mass, so they cannot. I don't know where is that number came, but no. Okay, let me give you the answer and I will take the chocolate. Okay, so it typically times minimum less 1,000 divided by 1,000 will be 10 power 5. So typically they will go with 10 power 5 meters per second in a good electronic circuit where copper nice way you make the roads. Okay, you call. Okay, a chip will be there, another chip will be there. Between the chip and chip, you create a road, which is like our roads. Okay, where buses will go, you go, I go, right? So, but these are the typical speeds. Now, if you use light to go, obviously 1,000 times more speed I got. Yes or no? I got, and I said there is no I square R effect. So two properties I got. So if I use photons, I can get two important things. No I square R effect. Second thing is 1,000 times more faster the circuit. In addition to that, are there any more? Can you think of? Now I don't want electrons. I want only photons to work for me. That's where photonics will come. Electronics, we want slowly change. We made a marriage where some amount of light we have used. Some circuits will use light alone. That's what we call optic circuits or your screens. Okay, LED screens, the liquid crystal screens. There are so many screens which all work with light. Okay, that's why how the internet, in my childhood it's not there. Internet to happen because of one wire. What is that wire? this will get, wire will get, if, fiber optic cable, optic is called, that is where. So, like you have for electrons, you have metal wires, all you see where wiring nalla irukka illiya, any where wiring, that wire is copper or aluminum or some metal we use, right? But if you want to use internet came only when optical fiber is invented, right? Optical fiber gave the origin for internet, okay? Yes, so because you can send now, instead of wire, you use the electromagnetic waves through that wire, and you can send signal from one end to several kilometers. But because the signal is in the path of light, now it is in the form of photons, they will travel with. So internet speed have gone up. Once upon a time there is no electronics. Only electronics was there. But with electronics you cannot make an internet. That's never come. If I want America, somebody mobile, he will put a picture. In India, in no time it will come. Right? But America is connected to you. America is connected through optical fibers or through electromagnetic waves. Electromagnetic waves, Bluetooth. Bluetooth, you use your headphones without wires and you switch on Bluetooth. What is how Bluetooth in your mobile and your earphones are connected? Again through photons, which is Bluetooth, which is the electromagnetic wave. Right? So we use small circuits and very long circuits which are optical fibers where light is used. And whenever you send light, there is no I square R effect. You can check optical fibers, they don't get heated. Okay? So we all go with respect to that, and in that only one topic. So I am going to talk about certain materials which are going to be useful if you want to make a photonic circuit. So ultimately I want to replace an electronic circuit with a photonic circuit. If you take electronic circuit, what are the three important materials used in an electronic circuit? Take broadly, you have to tell me, in an electronic circuit, based on electrical conduction, we define all materials into three kind of materials with respect to electronic propagation. What are those three materials? Semiconductors is one, conductors are two, okay, correct. So insulators, semiconductors and conductors. Right? So this is where now, so for electronics, any electronic circuit you take, these three materials needs to be used. We require insulators because we don't want to get shock. Right, all you switch, you see, the switch is an insulating material, but inside the wire will be there, which is a conducting material, right? So in a circuit, we need to control the circuit. To control electrons, you require a semiconductor. If you know semiconductor, only conductor and insulator, you cannot do no electronics. So semiconductors are extremely important. It is like if I give a car, you want to drive, I will remove the brake. I will be starting accelerator semiconductor, which will be used for controlling semiconductor, which will be used for controlling the flow of electrons in a circuit. That's where electrons came. Right? Now, so I require, now if I want photonics, I want the equivalent of electrical wires, which already we got. Somebody has answered. What is optical fiber? You can send light from one end to other end for several kilometers. Right? So we have optical wires, which are nothing but optical fibers. We have optical insulators. You don't see no light should go. But you are all opaque materials. This is an opaque material. You are shining light, but I am unable to see it from this side because all the light comes here and goes back, or nothing good. If it is a glass, light can go through, photons can go from here to here, right? Whereas you require a material equivalent to semiconductor. Can we, so far photonics has not yet come, is because we don't have semiconductors equivalent for light. And the talk is going to be quickly giving some aspects of that. That's where I work. And we want to That is called electronic band gap. Silicon, germanium, gallium arsenide. All these are semiconductors where there is a gap. So you send this electron to here, valency band, conduction band to conduction band. When it goes to conduction band only, it can run. If it is in chair, if your mother scolds, you will run from one place to other. So the scolding is like giving a input to you. Similarly, from a valency band to conduction band, if you put, you have to apply a little bit of voltage, 5 volts, 3 volts. We use batteries, okay? To put all these electrons from valency band to conduction band, then they can run. If you remove that, it will not run. So you can control the speed of electrons by putting them from valency band to conduction band. That's why you require a semiconductor. So can I use photons from one band to another band? We all know that in conduction band electrons flow, in air photons will go, so we require half band is air band. What is a valency band equivalent? Is a material. So here you have something called a dielectric band. So if you can create a dielectric band and an air band with a band gap, you can send light from dielectric band to air band and photons will flow. So now, but how do I make that material? You have to call Tata. You should ask them to do talk. You should ask them to check chocolates. But you people have to, I'm now about 68 years old, so I cannot do any more research. I can give you ideas. I can say you do this, do that. But you people are the people who have to do research if you want future to be in your own hand. You want to control photons according to your will and wish. Like that. That is the type of thing. Okay. Now we will go through my slides. Okay. Right. So let's now what I will do. So I do a small aspect of that is colors, which I said nothing to do with electronic colors. I said I eliminated that. Okay. I will give you structural colors. Then we will do photonics. Okay. Right. So okay. Maybe quickly where I'm working, just for 2 slides. I was in IGCAR, I said, Kalpakam. I did 40 years. Then another 5 years in University of Hyderabad. Then I went there. If you, how many people saw Arunachal movie? No chocolate. Who is the hero of Arunachal? Rajinikanth. What is his train thing? Arunachal is not the world. He has to spend how much money? 30 crores in how many days? Right? So Geetam has given me 60 crores and asked it to make research labs in less than 2 years. So you can see, so I am the Rajinikanth of Geetam. So I have created one lab here, I have created another lab here, I have prepared a lot of these. Okay. These are all 3 crores, 4 crores, 5 crores, lot of equipment I have purchased. But Rajinikanth has done with Rambha, without it. I do have to do it without it. So I am very rather than Arunachal. Because I know Rambha is given to me. Rambha is the hero in there, right? You remember? Yes. So the ultimate last bill for few things he has to do as her fees and he wins the show, right? So I have to do all this. So I set up all these facilities and I had all this group and create researchers and study various materials, making materials, etc. This is all. So Geetam is now, once upon a time it's an engineering college like here, but it is slowly transformed. You people have not become university. You still work with there, Bharatiya University, right? Your degrees. Bharatiya University, right? Whereas Geetam can give its own degrees because it becomes university. And it also becomes a research university because it has established using its own money, calling people experienced me and said, you are good, come and call you as Arunachalam, okay? Use that without Rambha, please do this. And I did, okay? Because I am at 68 and I don't want Rambha, okay? Right? So now, let's go and talk about basic subject. So, this is all done. So you people can do research and we also give fellowships of 40,000 rupees if you are very good If you are not so good, we'll give you 20, which we call Murthy fellows. Okay, so this is all electromagnetic spectrum, you know, we have spectrum, and this is what I'm going to discuss only this aspect. This is 700 nanometers to 400 nanometers. Actually, it should be ulta. This is actually 400 nanometers. This is red, 700 nanometers. This is blue, 400 nanometers. And they are traveling with the velocity of this. So this is all basic. And let me quickly show how IR spectrum will look. See, electromagnetic wave that girl has told. So you have a, when the light goes through this direction, for example, let's say this end to this end along the y direction, for example, I give you the directions, x direction, y direction, z direction. So x direction, let's say it goes in y direction, then electric field, which is blue, okay, it will be in z direction, magnetic field will be in x direction. So, and they will keep interchanging. So when an electromagnetic wave passes through in air, it has electric field and magnetic field together, they move in the same direction, but in x plane magnetic goes y plane. So these are transfers to the propagation direction. Propagation direction, only the energy goes, but the electric field and magnetic field goes in y and z direction, which are transfers to x, z, or whatever direction you choose. So that's why these are called transverse waves, and they go with velocity. We said right now, and because of that, because of transverse direction, you have light which don't have sound. Light has a property called polarization. Right? Yes? So you can polarize light only in vertical direction to come, or you can direction vertical to come direction. So I can go parallel and roll. Right? That is my one direction. I can walk like this. This is this direction, I am vertical. So polarized in this direction now. If I roll, sleep and still go along this direction, roll, that is horizontal direction. So I am a transverse wave light. I have to change from vertical to horizontal, or horizontal to vertical. So this polarization, using a polarizer analyzer, you can do. Okay? And today here you already see a laser. This is a laser pointer. This is a helium neon laser pointer, which is unlike the normal these light sources, which gives you the 700 to 400 nanometers. This can only, out of this, only one color, which is 688, that color we have. Okay? Only one color, right? We all, to get one color, we need to put the dye or pigment or anything, right? If you take the normal banyan cloth, that is white color. Yeah. Yeah, but I have to, yeah, this is where, okay. So the white light, like banyan cloth, if you want to make it one single color, you have to use a dye. But how do I do that? Here I need to use, you have to now tell me with your known science, given 7 colors, which you all know, sunlight has 7 colors, but how do I know what experiment I should do to know that white light has 7 colors? Anybody raise the hand and tell. I saw him first, okay. Huh? Why only glass prism? But that is a property of the light. What is prism doing?
Sir, it reflects and concentrates the light at one point.
No. Yes, we know light has different wavelengths, right? But now the different wavelengths needs to be separated. Why prism does?
Because of the geometry.
One is geometry, right? But I can make, for example, any other material. I can take, for example, gold prism shape, and I send.
It is transparent.
I can take a perspex sheet and make it a prism shape. So prism shape is important, but a material property, I am looking for one important word. Not dimension. No, what is that phenomena called? 7 colors splitting into 7 different colors.
Refraction.
Not diffraction. No. No, no scattering, no diffraction. I will come to the diffraction little bit later. Refraction, no. Dispersion. Who has used dispersion? You used. Dispersion. So the prism the prism is a glass material. Similarly, water also a dispersive medium. That's why you will get 7 colors, rainbow. When sunlight comes and water droplets come, they will act like a prism. And if the light goes through, you will get dispersed, which will be rainbow. Similarly, the same thing, if you make it in a lab, you create a prism and you send light and you will get 7 colors on the screen. Okay? But the medium, which is glass or water, is called a dispersive medium. That means the refractive index of that material, which is glass, depends on the wavelength. It is not constant. The average is okay, but for red wavelength, same material will have a different refractive index. Third decimal it will change, and whereas violet light, it will have another refractive. Same material, for different colors of the electromagnetic wave, it will have different thing. Hence, when you put a prism, it will deviate to different angles. Hence, you can discuss. So the prism shape is to first split and then separate it out. That separate is through a prism, because the top path length is small, bottom path length. In this shape, this path length compared to this path length is more, right? So when light goes, some waves which can go slowly can come through this way, which can go fast, which will go through that. So you will on the screen, finally you will see the split, right? So that is what the prism does, and same thing water droplets also do, which is responsible for that. So dispersion, right? Now, only 7 colors we are coming. And I know all this side of the ladies, they are not happy with 7 colors. Because in red itself, you purchased a maroon red pattu saree. By where you will go immediately? You want to buy a blouse. You will go to blouse piece, no? After purchasing saree, where do you will go? For a blouse piece. But what you will do there? I said you already purchased one color, which is maroon red. Then you are looking for a maroon red matching. But there will be 700 blouse pieces which are all maroon. Small deviation. Yes or no? Yes, sir. So your eye can only sense even a fraction of a wavelength. That's why different colors are coming. That poor guy, they don't have that resolution. They don't go to matching. Have you ever gone to blousing center? Huh? Not browsing center, blousing center. Where you have to buy a saree and you have to make a match for blousing base. Because you have to match perfect matching. Right? So the wavelength matching, these people can do better. Okay? So that type of different colors. So now even red, I want to make 100 red colors. But each is a different red. Different wavelengths among the red band. That how do I do? Now, somebody will, okay, one chocolate I am Baki. Who is the chocolate person? For dispersion. Dispersion, one chocolate. Next, already one person said answer. We said for further sieving of the light. Now you have to tell what is that phenomena you just gave previously. No, dispersion is that. Diffraction. Who said diffraction? Diffraction who said? Dispersion is making one white light into 7 colors. Now out of that one color, let's say red or blue or any color, that needs to be further made into 400 colors. All look blue, but I said, giving an example, blousing center, there will be deep blues, normal blue. There are so many blues here. This is also blue and this is also blue. You can see, right? But how do you differentiate? If I want to get this color and this color, you have to take the blue band and you can only use diffraction. Okay? So diffraction is one phenomena. Hey, the diffraction who told? Dispersion who told? You told, yes. Diffraction anybody told? I only told, no? Somebody told diffraction. You told? Yes. Okay. So you share. So diffraction is you take a grating, that is a small piece of thing, you create slits. When light goes through this, different colors will bend. Like now I open a little bit of slit there. You have to go, and who is thoda, that girl probably little bit, don't take a thing. If you have to go, thoda, you have to open a little bit more if she has to go out, right? So different slits are required for different thickness of our chest, right? We bend and then go. But even if we bend, if I am like this much pata, okay, then I need to open the slit. So like different wavelengths have to go through the thing. That's what we said. You require a grating with different slit wavelengths, slit separations. So in grating, we make such gratings, different slits, and send light, you will get diffraction. Hence, you can see even one band of light into several individual colors. Okay? Right. So that is what is dispersion. Now quickly I have to move here. I am still, okay. So these all you know, reflection, refraction, I am not taking much. And dispersion I already told, yes, 7 colors. And this is the diffraction, right? So through slit, if you send even one light, you will get different, that main color will come, and other colors, if there are 2 colors, the other color will come under places. Okay? For example, simple example is, you take your CD. CD, if you do like this, 7 colors. CD material is not, it's a transparent plastic material. But why that colors are coming? It is not because you coated with pigment, like your chunni. No. It is made bruise. That sound cracks. That's where your song is recorded on the bruise. Even the old days gramophone record. Okay? So that bruise, the separation between the bruise is the order of the wavelength of the light. Hence, that goes depending upon the angle. So now diffraction depends not only on wavelength, but also the angle of deviation. How much I bend. So diffraction is bending of light, and a particular wavelength depends upon how much is bending. Based on that, that color comes out. So diffraction is an important phenomena where we can see the colors. So the structural colors is a consequence of diffraction. So my title, structural colors. So I can use diffraction phenomenon to make. So to make diffraction phenomena, one is making slits, but you can only make one type of slits. I want in a 3-dimensional way. You people have studied X-ray diffraction. Similarly, I want light to be diffracted in all 3 directions. So I make 3-dimensional slits, which we call a photonic crystal. So a photonic crystal is a 3-dimensional grating. But grating between the spacings should be wavelength of the light, which is between 700 nanometers to 400 nanometers. And it also angle dependent. Because so you people might have studied Bragg-Sala. How many people studied? Anybody knows Bragg-Sala? I just have to quickly go there and show. This is the Bragg-Sala, right? For X-rays we use, if you have planes and the light, the X-ray wavelength satisfies this separation, you will get L lambda is equal to 2d sin theta, depending upon the angle, that is this angle, and the lambda of the X-ray, you will get diffraction, and that particular color get constructive interference, and you will see a big thing. Similarly, if the same thing, because now atoms are small and atom separation between the planes is small, hence we use it. Okay? But now, compared to X-rays, what is the wavelength of the visible light? This is a question, I will give you again a chocolate. Compared to X-ray wavelength, what is the, let's take red. Mean is actually green. Green is 550 dash dash. How many nanometers? How many angstroms? 1 nanometer is how many angstroms? 10 angstroms is 1 nanometer. So 550 nanometers is nothing but 5,550 nanometer, 50 angstroms. And X-ray wavelength is actually 1 angstrom. So wavelength of visible light is 5,500 times more. It is a bulky guy. Visible photon is this much size compared to X-ray wavelength. So you require slits to be separated by that much. So atomic separation is not sufficient. You have to make laddus and separate them. When you send through a laddu, it will nicely will go and diffract and you will get. So gratings for visible light is to make particles which are similar to like atoms. That means use atoms and make a laddu. So if I call atom, then arrange laddus. If you go to in the shop, it will arrange like an FCC, face centered cubic, we call. Laddus are arranged, it is a laddu crystal. Now you send light through that. But laddus, when I said, these are very big laddus. Tirupati laddu is still big, which is centimeters. I'm not talking about, still I'm talking about nanometers. So nanometer particles, laddus, because angstroms, atoms are angstroms. Okay, I have to make 550 nanometer particles and assemble them periodically so that I will get a crystal. And if you send now visible light through that, I will get a photonic crystal. And that will exhibit beautiful colors. That colors will not get, if you take your shirt, new shirt, put it in sunlight for 10 days, fade away. Put a lot of Nirma, washing powder Nirma, or your other washing powders, it will also fade away. But structural colors will not fade. That is the advantage. Right? If you wear today that type of shirt, where it is made up of gratings, who makes such thing? Give me one example in nature which doesn't use your type of shirt, but still it is very colorful. Huh? Sun doesn't give color. Sun is white, and if you see sun has these colors. I am asking you, leaves will give only green color, but that is because of pigment. No, it doesn't change. Peacock. Who said peacock? Yes, peacock is yes, peacock. So you have to make. Okay, so I will not ask too many questions because my chocolates are getting over. So this is peacock. I will tell you about peacock a little bit more, but there are many animals. There are many animals. Please stay. Okay. So peacock, by the by, peacock you showed. I should not use it. Peacock is a male. It is not peahen. Peacock is a male. It is a cock. It is a cock. Hen is a female. Okay. So peahens will not have that. No, peacocks will do, because peacocks want to attract peahens by showing I have so many colors. Right? If it wants to make, I will show you towards the end how it can detect, how it can attract peahen. So peacocks, you should not vary anymore this, that. Wear a photonic crystal shirt, you will get beautiful colors. Then you start dance, you may attract not peahens, but equivalent hens. Okay? Right. So peahens are not so attractive, but so males are also attractive. That's what I want to convey. We are not taggedele. Right? Yes. So, yes or no? Now let's go quickly. And so if you can make, so the question is now we'll come to talk again. Photonic crystal makes light to sieve first and different colors. Now, if I can make a break in this photonic crystal, that's what ultimately my idea. I want a semiconductor for light. First I made white light into single colors using a photonic crystal. Nice, created one particular color depending upon the angle. The difference between that colors and this colors I should able to tell. First, before I go into that, let me talk about that. First, structural colors I will complete. Where is that, the picture, where it is gone? Yes. So, difference between structural colors and chemical colors. What all we have chemical colors? Padukone also is. Deepika Padukone has only blue light. When I see this angle, blue. When I go that angle and also blue, the blueness has not changed because it's a chemical color. Chemical color is independent of angle of UV or angle of even incident. If the light goes like this or light goes like this, when I view this way, that way, the color is invariant. It is only for color. But take your grating. If you color this way, it will appear red. If you say it will be blue. So, photonic colors, peacock, that's why it does dance. It says I have so many colors. Each angle give you a different color. So, Behance is, oh, so many colors. Let's go and friendship. Can you date with me? Yes. Over. So, depending upon the number of colors, that means how much grating it has. It all depends upon the grating, and for a small angle, so many colors, that is the best peacock. So much if you do, still the same colors. Dating, can you come for dating? No, tomorrow we will see. Okay? I can come only for coffee. Okay? That's what the Peahan says. Okay? So Peahan and peacock chemistry depends exactly on photonic crystals and Bragg diffraction of visible light. Okay? Now, if we can make a little bit more, we can make a semiconductor for light, which will make the photonic circuits realizable, and you can make a cost-effective photonic circuits. Okay? That's what. Quickly we will do. Still we have another 15-20 minutes. So we came, starting with light. We came how to see the light, what are the properties of light, and we came to photons, and we talked about something about photons, and then how to make a single color photon. We talked about integrating, and band of colors means dispersion. Now the single photons, which are single colors, how do I control them using a circuit? And I said why we require photonics, because we said it is faster transmission and it has no I square R effect, so the photonic device will be no heating problem. And one more important, when you thunderstorm comes, you are watching a nice Vijay movie. Vijay is speaking with a heroine. Suddenly the song has gone, right? Because thunder has come. What happened to your TV? TV will stop or this song is off, right? Current goes, even current is there, the picture suddenly goes and off, right? Because your electrons are electrons are charged particles. In an electromagnetic wave, electric and magnetic fields are there. Electrons get deviated using electric field and magnetic field. Yes or no? That's why the picture goes off. But if you already use photons, photons are also electromagnetic waves. Thunderstorm also is for mainly the thunder, lightning is also electromagnetic wave. It doesn't. So, photonic devices, your TV, Vijay song with heroine will be, even if there are thunders, it will be there. No deviation. Right? No difference. So, electromagnetic, this is, in science language, there is no electromagnetic interference. Electrons get interference because of electric field and magnetic field of lightning, but electromagnetic waves itself, if you use them, which are photons, you don't have electromagnetic interference. So an uninterrupted TV transmission is possible without any real speeds and no deviation, no electromagnetic. Over and above, how many that highway, how many channels? Is a single road? How many channels? 4. Why? No. 4 channel road. Because 2 from that side can go, 2 from this side go. Alright, there may be 6-lane road. We call 2-lane road, single lane road, 4-lane road, single lane. What is the advantage of increasing the lane? Many vehicles can simultaneously go without any problem. So, frequency of light, since it's very high, typically 10 and its bandwidth is also very high, many photons of different frequencies can connect. It is like increasing from a single lane road, which is electrons. Okay? Whereas here, this is a 7-lane road, 8-lane road, 40. So the bandwidth of an electromagnetic wave is very high. So you can send simultaneously 7. That's how. Okay? That's how you see TV transmission today and even channels. Earlier, if I speak from my home, Chennai, to my mother, I have to speak loudly because it is going through electric wire and never no connection. But today you can connect. Many people can conference calls. Her voice is different, your voice is different. You can also plug in some videos, audios. So many channels you can put in because the bandwidth is very high. So all these signals can go simultaneously. Okay, so that is the additional advantage. So speed. Next is no I square R effect. Bandwidth is more, no electromagnetic interference. These are the major advantages of photonic devices over electronic devices. So you are all convinced that we should do research on photonics, right? In that, the primary component with respect to material is having a semiconductor equivalent. Don't say semiconductor. Semiconductor is for electrons. So an equivalent of semiconductor is called photonic band gap crystal. Photonic crystal and photonic band gap crystal. Okay, that means a gap exists for photons to travel from a dielectric band to a air band. Then you can, for which you need to excite the photons. Okay. Having said, so this is what structural colors. This is peacock. You see angle dependent, which appears here and X-ray refraction. But here the lambda is visible light, not the X-ray, and it is theta dependent. So structural colors due to Bragg diffraction and underlying mesoscale structures, and it will undergo a deviation, and you can. Okay, so you now understood structural colors because there is an underlying structure which is grating like structure. Okay, if you take this picture of a photon, this any small strand and observe under transmission electron microscope, you will see. I will show you that pictures also. Okay, so if you see them under microscope, electron microscope, these are the particles which are several hundred nanometers, and they are all arranged in order, and the separation between them is order of brilliance of light. So you have to make laddus. These are like laddus. These are all not particle atoms. They are laddus made up of that particles of several hundred nanometer, and they make them arranged. Hence, you will get. So these are all I make in my lab. I will get from a white suspension like milk. I will get beautiful colors, provided I arrange them in nice order. Nature does all this. See, nature does both your butterfly, your some of the thing, and some of the fishes. This is your hair of peacocks, and even chameleon does a color change surroundings. So you should change. For example, today you have blue shirt. Now you came. Oh, it's AC, and my teacher is not a male; it's a female. I want to attract her and get more marks. Change the color. She likes maroon red. Suppose she likes maroon red. You have to change your color. Can you do it? Chemical color cannot, but angle will change. Chemical. So structural color by angle you can change. You can do this. That's what chameleon does. Chameleon does change its angle depending upon seeing female changing with chameleon. It wants to attract with that light. That obviously, when you go, what color today I'm going for dating, what I do, whatever you other part will like, that color you will wear, right? For you, pink is very good, so you will wear a pink saree and pink dress, right? Similarly, the chameleon. Similarly, threat or right? For example, you go for interview. Sir, I'm sweating. That is your body response, right? Similarly, the chameleon, if it sees threat, because it's color. Now, if it changes color with surroundings, then you cannot see. So it changes its color. So to save from itself, from the predator, or to attract both, it will change its color. That means there are photonic crystals which are wavelength selectable. By moving this spacing, it can do. So it has two type of layers. One layer is one wavelength, another wavelength is another wavelength. So when I change it to another color, it will change the color and it will change the angle and changes. So you can have a tunable photonic crystals. Is this? Sorry. Please. Okay. So you can have tunable photonic photonic crystals, photonic band gap crystals. Okay? Only for colors, photonic crystals. If you want to control, then you have to create a band gap. So quickly I will do that. So I do that type of thing using my lab. So I create what nature created in peacock or peahen or the butterfly. Similar things I can make. So I am Vishwamitra. Vishwamitra can create what nature can create. He is the only scientist who can create equivalent of what nature. That's why he created even a Trishaku Swargam. People have heard, people should read Ramayana, Mahabharata. It's a lot of fantastic stories with a scientific background. Okay? So, only Vishwamitra is a scientist like me. Only thing is he has daddy and I am without daddy. Okay? Right? So, with type of that commitment, he could create several materials, several novel structures. He is an engineer, he is a scientist, he is everything. Okay? So, we can do what nature can do, I can do in my lab. Okay? That's what is my lab. That's why I require chemists, I require biologists, I require physicists. I take all the research scholars and do the jobs according to this. First, make laddus. Laddus, somebody will make. Which particles? Synthesis. Synthesis is chemistry work. Then putting them into nice photonic crystal structures like order is the physics. By the way, the center one is giving you different colors. But what do you know? That one? Can anybody can guess? Last chocolate is there. No? No chocolate? Chocolate is there. If what is the central structure? This Hodi-Gudu shape. Gudu-Gudu. What is that? It is a gem. I gave you the clue also. What gem is that? It is a gemstone. It is a gemstone giving you beautiful colors, which is a natural photonic crystal. Opal. Who said? Yes, he won. It is called opal. O-P-A-L. O-P-A-L. Opal. Opal is a simple sand. It is SiO2 particles. It makes, nature makes SiO2 particles, sand laddus, okay, and arranges them like the one you saw there. Okay, so they are called. So this sand, nature makes lot of sand which is not identical in size nor identical shape, but nature also at certain conditions can nicely make these laddus and arranges them and make this open. So though it is a SiO2 particles of same identical arrangement, depending upon the angle of that grain, you will see beautiful colors. So it is the same grating but oriented in different. So green crystal, red crystal, blue crystal, slightly in between color crystal. These are all same sand particles, sand laddus, arranged them. So how do I know? I can do SEM microscopy and see all that. This next. Next. Yeah. So these are all natural waves. You can see these are nature's do. If you take that hair, skin, you can do a lot of biophotonics. Those who are working on this is called biophotonics. What is responsible for such a beautiful colors? And the colors are not only for just attracting the thing, it also can survive from its enemies. So that is what the thing does. So this, if you take that hair and see under a microscope, nice structures underneath. For example, if you see, if you shine this one, this is a sea mouse, which is a small insect type of thing under sea. But it has hairs, which you have to hair proper, lot of colors you wear. But you don't, that hair, it has a beautiful hair with photonic crystals. So if you take that one and see under the microscope, it is a perfect periodic structure. This one, I will show you a movie, and this is what the opal, if you see under a microscope, these are sand spheres of 220 nanometers. So these 220 nanometers are nicely arranged and oriented in different directions. And you go back. Normal sand you can take anywhere. Okay? Nobody. Similarly, graphite, you use pencils, which is a one order arrangement of these carbon planes. All three dimensions, if they have covalent bond, you get diamond, which is several lakhs of rupees. Same carbon. So for a scientist like me, I never wear any carbon because for me, that is also carbon, this is also carbon, all are carbon. Actually, cooking is very much important. In my childhood days, I used a lot of coal because those days no electricity. Then scientist, I have to write, so I use the pencils, so I use graphite. But I don't like diamonds because I don't have that much money. So diamonds are not really, they are all carbon. Similarly, sand, normal sand, photonic crystal sand, opal, and opal, there is a quartz, is a crystalline sand. So quartz we use for several applications. Quartz crystal. So take a tiny, nice cut crystal, it can vibrate if you apply volt. This is called stress-induced electricity or piezoelectricity. So these are all physics under physics. Now, let me quickly go to next thing. This is all done. This is all done. Now, in my lab, what all is required? I need to make reduce. So I make colloidal synthesis. So you know sambar you make. How do you make sambar? Take dal, put it in grinder. Then you have to put later on. First you have to make the size. Then you have to do cooking. But still, you cannot make colored sambar. Beautifully. Serve me. This angle it should appear red. This angle it should appear blue. Your sambar doesn't appear. That is because the particles which are made up of dal and tamarind is a soup, they are not identical. Challenge here in chemistry is making particles identical in size. I give you a picture, right? So monodisperse size particles. That is very important. All atoms are identical. That's why you get nice crystals. All molecules like water. That's why you get a ice crystal, which is very transparent. Okay? So all molecules and all items are identical in size and shape. But if you want to make particles, we are all not identical in size, not identical in shape, not identical in color. Because as the dimensions go, the polydisperse, this means different colors, different sizes. So the challenge in chemistry is to make all identical. If you can make identical only, you can make nice identical slits. When you shine light, it will give you the beautiful colors. So I make first a suspension like this, sorry. So I make a suspension, I put them, then I become a physicist suddenly. Once a student gives me that colloidal white suspension, I make interactions play around. Like for example, I will give me ice to me. What you will do? You require a fridge, right? And that with a cabin top and 4 degrees and below. Then only, so similarly, just by particles, identical temperature, you put the right temperature and right pressure, right density, which is what I do. That's where the physics comes. Density, pressure, temperature, which we call thermodynamics, phase diagram of water. Similarly, I create phase diagrams of particles, and where does the crystal form? That crystalline phase I take and I make them. So that is what all my research. I will not go anything more on that. So let's go that, and you can make this type of things using the electron beam lithography, etc. Because you require nanometers. So you require a pencil, which is electron beam itself. So you can make such structures using electron. But to make a two-dimensional, you cannot make three-dimensional. Okay? If you take a sheet, you can write only one. You can get, unless you create another sheet and make it, and then you can make a book. Book is a three-dimension. Page is a two-dimension. In that one line you write, that is one dimension. So three-dimension is what we want to make three-dimensional crystal. So you require these electron beams, which you can make only two, because you can lines you can draw, and the separation you can make it optical wavelength, and then you can make a photon crystal using these, using any of these techniques, 3D printing, electron beam. But to make a structure of 100 micron you require something like 10 to 10 lakhs. So one small tiny chip will make few hundreds of lakhs. can make three-dimensional photonic crystal, and you can create a band gap, which I don't want to talk about. These are the two people who may get Nobel Prize. Okay, they said photonic band gap is possible. Yes, I quickly go there, and yes, this is what you can see: A band and directed band. Okay, this is the calculation for a one-dimensional net wavelength. That means alternate layers of refractive index or dielectric constant you can make with a periodicity. Then you can create, but then you can get a band gap. If it is three-dimensional band gap, you can create based on the refractive index, etc. So I will not spend the time. Let me go to some nice movies. Okay, photonic crystals. I said a chameleon has two type of these photonic crystal layers. How do we know? And how do I do that? Sir, it's moving? I think so. Yeah. You see, what we took a photonic, of course not me, somebody anywhere, and then created a thread. Then you see, original color is there, it's frozen there. You can see under the screen, it goes green. Yes. So under the skin, there are layers where the particles are there. If they change their spacing, that is the spacing, different unity will take place, hence different color will come. So this happens in 400 milliseconds. So people have studied. We see civilians, we run away. Right? Why to run away? We do science out of that. They do science and they do that. So our science, why are you touching civilian? You have to go to hospital. Your mommy will say, are you running? No. Being biology, don't be afraid of things. Use safety things and you can study them. And there are a lot of mathematics underlying all these things. We have, how many mathematics people are, okay, you are at plus 2, so do separation. So a lot of mathematical structures are required to create different structures. So you can do that, yes. Then you go there. Oh, okay, I'm going the other way. So this is where I told. So you can have two layers. One layer is like this, one layer is like this. So you will get one color to other color. It changes equal to this. Okay, that's what in chameleon. So chameleon has photonic crystal. Next, this is what I said. If everybody electronic materials are like Buddhi, atoms and molecules, I make with laddus and create a photonic band gap, which is here. Okay? Similar type of thing will be there. This is an electronic band gap material. This is a photonic band gap here. But this is made up of this ordered arrangement of this. Okay? Then, I'm just switching on that. So using light itself, I said everything is light. I do everything with light. To do Vajrani, if you want to cut the diamond, you use another diamond. Yes? Yes or no? This is a saying in Telugu and in Tamil. Okay. Similarly, if you want to study materials which are made for light, I have to use light itself to study them. So I use the laser light, okay, and I use them as a scale to study the lens. I use the time, how much they vibrate, and I use the microscope, image them. I showed you how particles are arranged. I use them to even arrangement. For example, if you want to arrange laddu, take this 5 things. Like that, 5 laddus are there, 5 laddus you have to arrange them. You have 5 fingers, right? Okay, or even 2 fingers may be sufficient. But how do I make nanoparticles and arrange them? That means you require nanofigures. Okay, so I can use light itself to create nanofigures, which is what I will show you, which we call optical tweezers. So you can use optical tweezers. I will skip this slide. You can see. Take a nanoparticle, take laser light like this, okay, and use a lens and still tightly focus it. There you put your suspension containing nanoparticles. You can hold them. Stop. It will stop. Only dance. elephants, you have somewhere in the Kerala, elephants are trapped, put a big hole and cover with leaves. It thinks it is alive and it comes and it falls into it. That is how you trap the elephant. Similarly, this elephant is like now my colloidal particle. Trap is created by this light. So if you create them, you can create. That means I can put one particle. Can I put several particles? Put several traps. Right? So I do several traps here. Sir, please click on that. Click on this four. No. Go other way. Next. No. Please previous. Click on the next video. Here. This one. Click on. There is a video there. Okay. You are seeing? No. Playing, but I don't. Maybe actually there is a small motion you can see. So, and you can create, instead of one tweezer, create several tweezers by splitting using refraction. Then you make. This is where a lot of mathematics is required. You can create a square, you can create a triangle. One is square, triangle. You can create three-dimensional structures. Then you take these particles and ask them to fall in that line. Then you freeze them. Okay? Then you have a photonic crystal. So photonic crystal using the light itself, what is called we can make. Next sir, please. Next. You can see I have created particles and created a shape like a key. And now you can play around using light. So I can take the trap and move there. I can move the trap here. So the particle will come and stay there. So I can make different shapes. That's what you see here. Okay? So using light itself, you can take the particles and play around. Nanoparticles. I can make laddus like this. I can make laddus like this. I can make laddus this one like this. So you do with your fingers. Right? And wherever this, of course the brain is required to make different structures. Same thing we do here using light. Okay? So light can be used to create materials of light. And probably photonic crystals, though nature has created, we don't have material photonic crystals naturally. We don't have a pickle. We don't have a sambar naturally made. Dal is there, tamarind is there, mummy is there, which are all naturally given. But tamarind, you have to make sambar only if you make it. It requires science, right? And a kitchen. And all these ingredients to make. Similarly, photonic crystals are not natural materials. You have to make them. Bundi is given God. You have to make laddus and arrange them. The laddus could be different shapes. Right? It need not be always spherical. So you can make all these structures. These are all called man-made materials. These are also called meta-materials. Okay? So these are all meta-materials. Right? Next thing is, sorry sir, next sir. Go next. Other way, yes. So go next. So just structural colors. Can I quickly, last 2 minutes, sir, have you got photonic band gap? Answer is we got small gaps, but still a lot of research is done. But we can use whatever you have made. For example, you want to make idli, but unfortunately the idli thing becomes very fluid. You cannot make idli. What you can make? You can make dosa. Yes or no? Yes. So like that, I can make photonic crystals to do some application. What is that application? I can use a sensor. So I put them into a gel medium and make a nice thing. The gel can swell and shrink. You people use gels. These people, right? All your diapers have a lot of gel. Okay? So in that gel, okay, you use gels. In that you put this photonic crystal when you do. Okay? Then gel can swell because after taking your urine or whatever you take, the gel can swell. Then you split it, water will come out. Similarly, here also the gel swelling, the lattice constant will change. So change in lattice constant, that is greater than the color, you can say what is the quantity I use. So you can calculate quantitative in experimentally by seeing it. So if sugar patient is there, normal sugar is around 120 or 180, right, millimeter. Now somebody has 300 sugar. What do I do? Every day putting needle, all this diabetic. So what you will do is you take your tear make a gel and with photonic crystal. If it is a normal sugar, let's say it's showing red. Okay. Now you put this sugar patient, you go take his tear and put it there. It will swell because he has more diabetes. Then it will go to another color. So if it's got deep blue, you have to go to hospital. You are diabetic. So without taking needle, you can. So diabetics, sucrose, many urine tests, tear tests, without invasive, which we call invasive, that means by putting needle, without any needle, take tears, urine, any of the sweat, any of these biofluids, you can use them as sensors. So photonic crystal sensors, we use them for just by changing the color. So this is what is done there. Okay, we use that. We can make A1. You can also make strain gauge. One red color, that red color is nothing to do with your kidney. I said photonic crystal. Only one angle, one color. Now you strain them. Some things have changed, that is constant. It's like chameleon. So this is chameleon. You can see two colors. One color green, one color red. That means how much you have strained. That amount of strain if you want. It's called strain gauge. So you can use photonic crystal strain gauge. Just by seeing. Japan, these people in the news, okay? Japan has a lot of earthquakes, right? Unlike us. So all we use white paint, but they use this photonic crystal paint. So they will, if there is no earthquake there, you put it, and then after earthquake there, some colors will change. That means some buildings have changed because we have some shaking it. If it has gone from red color to deep blue, that means that building is not livable. It will collapse. Okay. So by seeing the painting color, you can say that you can occupy, or how long you can stay there, or you have to vacate. Okay. So people in photonic crystals use photonic crystals for strain gauges and strain gauge paints. Okay. Now I quickly go to my last slide. Okay. You can make one. Sir, here. Press it here. Yeah. See, I make dosa, another dosa, then dosa. All stack of dosas. And then put the dosas in between some whites type of thing, which is polymer whites. Now dosas at this color, at this separation, this is one dosa, this is one dosa. This much straight, one color. If dosa becomes like this is one color, but the wavelength has changed. So you can use NH4Cl to change the color. You can see I have 4 NH4Cl. The red color has gone to green, which is exactly what chameleon has done. So a stacking of dosas equivalent of photonic crystal layers with hairs, you can make them. Okay. Now if you wear this dosa becomes a big jacket cloth. Right. Now with the sweat, it will give a different color. Without sweat, NH4Cl is so you can wear one strap for different color. Because that's the thing. Right? So you can use that aspect. Next, sir, one more photonic crystal, which is a male, and it does peacock dance, we all know, right? Many movies, many songs, okay? And this is the photonic crystal. It uses light to safeguard itself and also attract, okay? This is not only that one creature I told you about, other birds. When you see now similar colors, beautiful angle dependent colors, they are all structural colors. Underlying them is photonic crystals. But that colors, beautiful colors will come. How does that structure, what is the mathematics to denote? I made one beam and then a square. How do I mathematically do different structures so that I can produce different colors? And these colors you can put it on the display. You don't require anything. Under sunshade and sunshine, water day, that colors will remain. Peacock will never take bath with the soap. It is as fresh as the colors will be as fresh as that. Whereas you have to take wash the glass. So natural colors, structural colors are permanent. Okay. With this, I will say end to my talk. Okay, and say it is not that I only do. All my students who are produced, some of them at University of Hyderabad, some at IGCAR, who are in the blue, and these are all my students who have done. These are my students. Thank you.
Thank you, sir, for your valuable insights. Now it's a time for queries. Students can clear their queries with our resource person.
So now without chocolate questions. With the chocolate questions you have done, that is what you know. But what you heard from me, if anything which is bothering you, that I want to know, please answer. Whatever best I will answer, I will answer. Don't be feel shy. Science, if you want to do, shy you have to eliminate. Not only for movies. Movies, if you shy, camera on, then nobody will take you. Right? Similarly, shyness. Similarly, you want to become a research scholar and a researcher, you have to take interviews, you have to take questions. Right? Sir, taggedele. Enna? What question? Ask me question. No questions? Everything very transparent? Yes. There is one question. Come to the center. Give that.
Sir, what is photonic band gap?
Photonic band gap, you know electronic band gap in semiconductor, that is a band of electrons which they can conduct. There are bands which they can reside. Like in your house, you don't move. But you want to move, then you have to come out on the road and then start running. Right? So there is a road band and a home band. Okay? In home, you can only do a little bit. You cannot really run and jog. Okay? So these are like for electrons, you have a conduction band and a valency band. For photons also, photons to propagate and photons to stay. In a dielectric material with this periodic structure, they will stay. But if you bring it to air band, then in air they can flow. So that is how you have air band and there is a band gap. A gap which results between these two. That is what is called band gap. Band gap between two bands is called band gap. And that band gap is for the photons, then it's a photonic band gap. If the band gap is in electronic materials thing, then it is an electronic material, silicon, germanium. But these band gaps materials we have to make in lab. Okay?
Thank you, sir.
Yes.
Sir, does light travels at light speed and optic fiber cable? Sir, optic fiber cable and light speed travel.
No, light speed divided by the material refractor. I said light, probably I have very quick. Sir, go to the first few slides, sir. For fifth slide. Go back. Quick, go to the, you see here, Hello, this is frequency, which is light speed divided by lambda. But in a medium, which is refractive index mu, then it is C is not C, it is C prime, which is nothing but C by mu. So since it is a glass, it's a nice optical glass. I have not showed you some pictures. Probably I will quickly show that who made all that optical fiber. I skipped. See, this person. This is a Chinese person. His name is Professor Kao. He made this sand, purified it, elongated, made optical fibers, meters and meters, pure guide where when a photon goes, it doesn't see any impurity. Like when you go, if you see a speed breaker, you have to slow down. Okay? If it is a ditch, you yourself will go inside. Right? So no ditches. So if there are defects in the optical fiber, light will not propagate. The photons. So you have to make very pure waveguide, which is optical fiber, and that's what. So he got 50% of the Nobel Prize only for creating optical waveguides or inventing optical fibers. So
Thank you, sir.
this Nobel Prize he got, and the other two got. Okay, and these are the other three Nobel Prizes who got is recent. That's 4 years back. What they did earlier, my thing, if I want a passport photograph for your SSLC, you have to write some passport. You have to go, they will take in dark room, then they will say, come after 1 week, we have to wash, we have to expect, we have to developer. You do a lot of chemistry. Get a passport. By the time you say, passport will not be hold good. Right? You have to open eyes, all these problems. But today, you take 1,000 pictures using this. How? Because you have created electronic sensors, which we call charge-coupled device, based on photoelectric effect. So light, which is reflected from you when I take a picture, it will create electrons, and these electrons are bucketed. That means a lot of buckets, which are charge-coupled devices. Then, if it reaches certain thing, you will get a voltage, you will get a digital picture. So, for making that type of a device, he got a prize, which are these two people. They are making the detectors. I showed you, you can make particles and hold. This person, he got Arthur Ashkin. He done this experiment when he was young, but he got Nobel Prize when he was 98. He would have kicked the bucket. But just before that, he got the Nobel Prize for his invention that light can be used to trap a nanoparticle. Okay? So he got maximum number of things. And the other two, this is a lady. She is finding light when you send, you can make tiny pulses of light. That tiny pulse is extremely small. That's what is his boss, that is PhD guide and PhD student. Both got the Nobel Prize. Right? So this is only again for light and studying their state properties. Okay. No more light. So any other question, last one, final question? Otherwise we'll say bye.
Would aluminum really block electromagnetic waves? Like when you wrap your mobile phone with aluminum foil, like it cannot.
Yes, we can not actually fully, but we can only stop electromagnetic going. You cannot, if you want aluminum foil, you have an electromagnetic wave. That side, if you see, because metals doesn't conduct the electric field. So using an electromagnetic shield means not the magnetic effect. You can still, the magnetic part will be there, but electric part you can shield. So it is a best, metals are best electric field shielding. So if you put a charge and you put a metal outside of it, you will not see electric field outside the charge. So electric field is only seen inside the thing. So if you want using electron beams or electron, if you want to be not to be seen, you go and create a metal house and you go inside. Okay. Similarly, magnetic field, there are some materials which will also create. Okay, so electromagnetic using thing, actually light itself, you want to be invisible. Actually in DRDO, that is the defense lab, the enemy should not see you, but you should still, AK-47, you have to shoot him when he comes some range. How you are seen, if I am seeing you means I am throwing light on you and you are reflecting the light. I am sending electromagnetic waves, I am reflecting, receiving electromagnetic waves to rays. But now this light will go, but this gets diffracted this way, that way. It will not reach back. Then though you are there, which is called optical cloaking. Using these materials, you can make electromagnetic waves to deflect away, completely deflect away, so that you will not be see the actual object. That is what is called optical cloaking. So using electromagnetic materials, which are some of this thing, you can make yourself invisible. Okay? So invisible you can make using photonic crystal pans. Okay. My phone number I will give you. Okay? So with this, bye bye and enjoy your remaining lectures. Hopefully you people do research in this area. Thank you.
Thank you, sir, for your valuable speech. Gratitude is not only the greatest of virtues, but the parent of all the others. On behalf of our DST Inspire Internship Science Camp, I extend a sincere gratitude to our resource person, Dr. B.V.R. Tata, sir, for sparing his time from his busy schedule to grace the occasion and enlightening us. Thank you, sir.
Now it's time for break. Students can go for tea break and arrive within 15 minutes. Refreshments are provided in the auditorium.
Call upon Ms. K. Saumya from PG and Research Department of Biotechnology for Chief Guest Introduction. I welcome you, Ms. Saumya.
Good afternoon, everyone. It's our privilege to introduce our chief guest, Dr. a highly acclaimed assistant professor, Department of Genetics, School of Biological Science, Madurai Kamaraj University. He has published 110 research papers, 327 cumulative impact factors, 3,900 citations, 31 H index, 76 I-10 index. He worked as an assistant professor, Department of Genetics, School of Biological Science, Madurai Kamaraj University. Lecturer in microbiology, PKN Arts and Science College, Thirumangalam, Madurai. He has done his all master studies. He has been honored several awards in 2007 Young Scientist Award, Association of Microbiologists of India. In 2023 Best Reviewer Award System, Microbiology and Biomanufacturing. He has completed research mammals, February 27 to March 1 in 2019, and 40 mammals, February 27 to March 1 in 2019, and 49th Aquatir Annual Conference on Biological Science, February 27 and 28 in 2018. He has conducted several workshops like Course Director Workshop on Bruce Lee Bioinformatics in the year 2017, Organizing Secretary Winter Schools on Microbial Genome Typing in 2008. He has membership in academic and scientific societies like member in editorial board system of microbiology and biomanufacturing, life member in Indian Association of Applied Microbiologists. His publications are Genome Sequencing and Comparative Genomic Analysis of Bovine Associated Non-Aureus Staphylococcus and Mammaliococci, Pan-Genome Analysis of Invasive Streptococcus Mutant Science Current Science. We look forward to his inspiring address. Thank you all.
Thank you, Ms. Soumya. The best gifts are brought from the heart, not from the store. Now, I request Dr. S. Karthik sir, coordinator of DST Inspire Science Camp, to present memento for a resource person. I welcome you, sir. Thank you, sir. The quality of a leader is reflected in the standards they set for themselves. It's my pleasure to hand over the session to our resource person, Dr. J. Rajendran sir, Assistant Professor, Department of Genetics, Madurai Kamaraj University, Tamil Nadu. I welcome you, sir.
So very good afternoon to thank you. Good afternoon to one and all. So at the outset, I thank the management, principal sir, and head of the Department of Biotech and other departments, overall the organizers, for giving me an opportunity to meet all these young minds. So nice to meet you all. So today, as a part of the Inspire program, we'll be discussing regarding genetics, basics of genetics, and what is the current trends in the genetics all over the world. How people are working on genetics, what are the developments in genetics, all those things. So this 1 hour, maybe the next 1 hour, can be an interactive session, need not be a monotonous lecture. So if you want, you can stop me at any time and you can ask me a number of questions. At the same time, don't ask any questions to your neighbor. So what everything is about. So we all know that we resemble our parents. So just by seeing some person, are you a son of this person? Are you a daughter of this person? Something like that. Because many of our characters like height, weight, skin, behavior, everything looks like our parents. Is it right or not? Yeah. So that principle is called as heredity, meaning we get characteristics from our parents. Okay, that is actually heredity. The science that discuss or study about the heredity is genetics. Is it right? So all of you might be knowing about him. Who is he? Anyone? Yeah, father of genetics, Gregor Johann Mendel. Okay, so he is the one who made, don't ask any questions means there should not be any sound from other side. I am speaking or you can talk to me. Is it right? Yeah. So Mendel, he is the founder of genetics or father of genetics. All these things known to you. These also might be known to you. So these are the 7 characteristics that he studied. So he has used all these. at least most of you might be remembering about the tall plant and short plant. That was the first experiment or first sort of experiments which established the science of genetics. He got only tall plant, and when he repeated the additional rounds of experiments, he got short plant also in second generation. So based on that, the genetic principles established. Law of dominance, law of segregation, monohybrid experiment, dihybrid experiments. All these things might be there in your textbook from 9th standard at least. Okay. So that was the basis of genetics. And these two persons who independently worked in various two different countries. One person is Theodore Boveri and another person was Walter Sutton. So can anyone tell what is their contribution? Yeah, chromosome theory of inheritance. Okay, so they independently actually, for example, he was working with sea urchin, an animal, coelenterates animal. He thought that at the time cytology or cell biology, microscope, all those things were well established. So he thought that chromosome could play some role in genetics, inheritance or heredity. So he removed chromosomes, and then as expected he saw some abnormality in the animal development. So that was his hypothesis, and then he proven that. So saying that chromosome theory states that genes are located on chromosomes. The segregation of chromosomes mirror the segregation of genes or particulate factors. That was a usage given by Mendel. Later people have named as genes. Okay, so that was chromosome theory. Similarly, Walter Sutton was working with grasshopper, and he also proposed the same thing. Together, chromosome theory of inheritance was established. Now we know that genes are located on chromosomes. And T.H. Morgan, so he is another founder of genetics, specifically Drosophila genetics. So he is the one who established genetics of flies at Columbia University, New York. And then he is the one who proven the chromosome theory. So here the previous people have proposed some hypothesis and theory using multiple experiments on an eye color of Drosophila. He and his students, their group have proven that chromosome theory of inheritance. Finally, people have accepted genes are located on chromosomes. Yeah, so this is another development. Now, people knew about genes. Genes are located on chromosomes. And then what is the chemical nature? What is actually gene? What kind of molecule makes genes? So that was the next question. And then in 1929, a person called Griffith and his team. So they did some experiment with a pathogen called pneumococci. So they found some virulent strain and avirulent strain. Virulent strain means it is a pathogen. When you expose the pathogen to an animal, it will kill the animal. Whereas another strain means another variant was non-pathogenic that was not able to kill the animal. So this is non-virulent, this is virulent. When similarly the third experiment is heat-killed smooth strain. I mean you kill the strain by heating for 100 degrees Celsius, heating at 100 degrees Celsius for 10 minutes or 15 minutes. Now cells are killed. When you inject the killed cells, heat-killed cells, it could not cause disease, and then animal survived. Okay. Then what they did was, they mixed the non-virulent strain and the heat-killed smooth strain, that is virulent strain. They injected together. Then they got pathogenicity, meaning the animal, disease was caused, animal could not survive. So this was a series of experiments where Griffith proposed that some principle he named as transforming principle that could transform rough strain, that is non-virulent strain, into virulent strain. Okay, in this experiment, they have shown that some chemical, some principle or some material has converted the non-virulent strain into virulent strain. So that is the basic experiment. And then 10 years later, in 1941, a group of 3 scientists, Avery, MacLeod and McCarthy, they did the same experiment, but they have treated this heat-killed smooth strain with proteinase, DNase and RNase. So these were the 3 types of macromolecules present in any cell. Okay. When they have treated with 3 different enzymes, when they treated with proteinase, that could not transform. Similarly, when they treated with proteinase, that could transform actually. Originally, non-virulent strains have become virulent strain, meaning proteinase treatment did not inhibit the transformation. Then they have treated with RNase, they have got same data. When they have treated with DNase, which cleaves DNA, deoxyribonucleic acids, when they have treated with DNase, the transformation principle was stopped, inhibited, meaning the transformation principle was originally a type of molecule called as DNA. Okay, so that was established science. Now we know that this was published in 1953 about double helix structure of DNA. Okay, now we know that a part of, like a segment of a region of DNA in the chromosome, that is actually genes. Okay, if you see the definition, these are the definition. So genes are the basic unit of information. And then people now talk about genome. So there is a concept called gene, another concept is called as genome. Gene is a single or a particular region which codes for one protein or one function. Genome means, so how many chromosomes we have? Anybody? Yeah, thank you very much. 23 pairs of chromosomes, 46 chromosomes we are having. And then the genome means the total genetic content, total number of genes, and of course non-coding regions. So it calls the total number of genetic information present in all the 46 chromosomes makes the human genome. So that is the definition. So now earlier people worked on genetics that was dealing with one character. Say for example, one genetic disease, and then people studied which gene was responsible. That was the science of genetics. Now people try to address in terms of whole genome. What could be the role of the entire genome? What could be the role of the entire 46 chromosomes and their genetic content and their genes in a particular phenotype? So that science is called as genomics. So by definition, the collection of total genetic information is genome. Okay, and then we know about chromosomes, storage unit of genes. DNA is packaged in the form of chromosomes along with proteins and other components, and the number of chromosomes makes a particular genome. Human genome has 46 chromosomes. Mouse genome has some number of chromosomes. Drosophila has 4 pairs of chromosomes. Likewise. Okay, clear? Are you following? Yeah. And then DNA is the type of chemical that is making genes. Yeah, and then the next major development after 53, the double helix structure, people have established genes, protein synthesis, many things. With respect to technology, 1977, a person called Frederick Sanger, he is the one who developed DNA sequencing technology. So we know about genes, chromosomes, DNA. Now the next question is, what is making DNA? DNA is made up of what? So that was the question. Then DNA structure was established. What makes those DNA structures? That was the next question. So Frederick Sanger has made a contribution on DNA sequencing. In fact, he is the one who developed technologies for protein sequencing also. He received Nobel Prize twice. Once for DNA sequencing technology, another for protein sequencing technology. Okay. So now we know that the DNA is made up of A, T, C, G. 4 different bases. Repeatedly, just these 4 different bases only makes the DNA. Different combinations makes different individuals. Clear? What will be the difference between a person with another person? Each one of us are having 46 chromosomes. Will there be any difference with respect to genes or number of genes? Arrangements also will be almost same, or some variations will be there. What else makes difference? Say for example, I am here, there is another person, one student is there, school student is there, college student is there. What makes each person as individual person? What is the difference between individual persons? Yeah, there will be minute changes. We call them as polymorphism or single nucleotide polymorphism. Mutation. In some persons, in some regions, A will be converted into T, G will be converted into C, something like that. Together, only these sort of changes, which will be less than 0.1%. So each human being, each one of us, 99.9% we are all same, we are all having same genetic content, but that 1% changes, and of course there will be changes in the arrangement also, little bit, variations due to a principle called recombination. Okay, some changes will be there. Only these changes makes individual as different individuals. Clear? Yeah. Okay, that changes can be identified by DNA sequencing technology is the one called Sanger. The sequencing technology itself is called as Sanger sequencing protocol. And then you might have heard about genetic engineering and biotechnology. Of course, the Department of Biotechnology is conducting this program. So Department of Biotechnology program is mainly focused on genetic engineering. So once people know about genes, a particular gene can be expressed in another cell. Say for example, human insulin gene or somatostatin gene can be expressed in a bacterium called E. coli, Escherichia coli. Okay. Therefore, that science was called as genetic engineering. So you have a plasmid, host plasmid, and you clone a fragment of gene coding for a particular protein, and then this construct can be transformed into a cell called E. coli. There if you culture the E. coli will make your protein of interest. Insulin can be synthesized from E. coli. It's clear. So likewise, that science is called as genetic engineering. So in fact, biotechnology was blooming or still blooming because of the applications of genetic engineering only. Okay, because we can edit genes, engineer genes, we can mutate genes, whatever the modifications that can be done using genetic engineering principles can be executed for the betterment of humans. So some applications through genetics can be derived from genetic engineering approaches. Yeah, this is another major leap or developments in biotechnology, that is discovery of PCR. There is a technique called polymerase chain reaction. Using this technique, one molecule of DNA can be made it as millions. It can be copied. Okay, so that's called polymerase chain reactions. Nowadays, each and every biotech laboratory should have at least one PCR machine. So possibly you will be exposed to this machine and they may demonstrate how it works, all those things. Yeah, single molecule will be converted into thousands of molecules in around 2 hours of period, 2 hours or 3 hours. Millions of copies can be made. So that is the power of polymerase chain reaction. Yeah, then later the Sanger sequencing was made it as automated sequencer. Like Early days, what people have done, they need to run a longer gel like this, this much lengthier gel. Running the gel itself will take 2 hours, 3 hours. And then later they will decode which sequence it is made up of particular gene. Later around 1995 or 1998, those time people have developed automated versions, meaning a machine can run the sequencing, run gels. Okay, instead of doing manually, you will be loading individually, and then whereas the machine can be trained to do all this. Okay, so once the automated versions were developed, then people thought about genome. As long as only the manual sequencing protocol was there, because sequencing one gene itself will take 1 week in well sophisticated laboratories in US, Japan and other countries. Once the automated versions was there, then people thought about why not we sequence the entire 46 chromosome. Why don't we understand the entire genome of human being? So that is the emergence of genomic sciences around 1990. Okay, that was the period. So then at that time, he is the one called Victor McCusick. He is the one who recorded human genes. So at that time there was books actually. Nowadays we maintain databases. What is the difference between books and databases? Books means you write and publish through some press. Nowadays there are databases where you can update the new discoveries. So that is called as databases. Okay, so he is the one who initiated mapping individual genes to a particular character. Say for example, albinism or short people. I'll be showing some of the slides. So they have identified the genes and then database were created. Yeah, say for example, albinism is a defect in melanin synthesis, a pigment responsible for skin color. Okay. Similarly, due to lack of some growth hormone, these people will be short. Okay. So these were some of the examples of initially discovered genes. Now we know about each and every genes that we have, and then what it codes for, how it functions, all those things. And then the science, genetics have become suffixed with omics principle. So genetics have become genomics. So what is the difference? Instead of studying one gene, you study the entire genome. Okay. Then transcriptome, studying one RNA, you study all the RNA. And then proteome, instead of studying one protein, you study all the protein. And then metabolomics, something like that. So omics studies were introduced. Can you follow the difference? So genetics focused on one particular gene, genomics is focused on the entire genome. Likewise, how gene is expressed is, gene is converted into RNA, RNA will be converted into proteins. So these are the basic steps. Instead of studying one by one, you study entire repertoire, that is all the collection of DNA or RNA or proteins, that are called as genomics, transcriptomics, proteomics and metabolomics. Okay, so this was the milestone or basic history behind genomics. So as I said, in 1990, the project called Human Genome Project. Human Genome Project was initiated in 1990 by an agency called NIH, National Institutes of Health in US, and various other universities and research institutions across the globe. Germany, Japan, UK and many other labs. Anyway, I don't want to read all those things. Yeah, this is the year 2001. In 2001, can you see the 1990 it was initiated. After 20 years, I'm sorry, 10 years. 10 years with the involvement of 100 different institutions, thousands of scientists have worked together to make the genome of, to study the, or to sequence the genome of human being. Okay. In the year 2000 and 2001, the draft human genome was released. So that was a major milestone in genetics, okay, in biology itself. And then the era or the period after the genome sequencing was known is called as post-genomic era, meaning we are in post-genomic era. Before that, people only studied about genetics, individual genes, all those things. Now we can understand the whole genome, entire genome, and everything can be understood. So that is a, now we are in the era of post-genomic era. And then a couple of years later, finished version, final complete mapped genome was introduced in 2003. Similarly, with respect to bacteria, so first bacteria was sequenced in the year 1995, and then continuously, because do you know what is bacteria? What is a bacteria? Anyway, I need a concrete answer and concrete conclusion. So what is a bacteria? What is known to you at least? So it's a microorganism. What else you know? I need all answers from you, because in subsequent presentation we will be focused on genomes of microorganisms, genomes of bacteria. So you should be able to follow it. So then only, I mean, you should have some concrete definitions for what is bacteria, and all those things, related information should be known to you, then only you can be able to follow. Any other information? Yeah, some bacteria are pathogen. What are pathogens? Disease causing organisms. Okay. So earlier people thought that all the bacteria are pathogenic. Okay. Some people used to call them, call everything as germs. All of them are not germs. Okay. So bacteria, some of them are pathogens, many of them are beneficial organisms, including probiotic. Yeah, someone might have talked to you. So anything else? Yeah. So DNA in bacteria is circular. Instead of a chromosome structure, a circular chromosomes and some plasmids might be there in bacteria. Anything else? They are single-celled. We are multicellular organism. Just single cell bacteria will be there. So bacteria will be of just single cells. And then genome size will be lesser. Smaller cells, so smaller amount of DNA will be there. Okay. So why people are studying bacterial genome? So earlier people focused on human genome, human genomics. We want to know which genes are responsible for making some disease or causing some disease, like cancers or susceptibility to cardiovascular diseases, diabetes. Many things, many diseases are there. People wanted to know what is responsible for this sort of diseases, getting disorders, susceptibility for getting disorders. Okay. Then later people started working on genomics of bacteria, microorganisms also, microbial genomics. Clear? Yeah, there is a, as I mentioned, there is a database of genomes, bacterial genomes. Every genomes are there. It's called a gold database, genomes online database. So that is actually gold. Now if you can see, 4,27,931. This much number of genomes have been sequenced. And then, of course, all these sequences are available in the database. Everyone can freely access this. Freely you can use this data, you can analyze, and then you can use it for your research. Okay? Yeah. This was my question. Why sequence this much number of bacteria or microorganisms? So some people wanted to develop, originally they have included when Human Genome Project was initiated in 1990, so they wanted to sequence E. coli, a representative from bacteria, and then collecting DNA or extracting DNA in bacteria is easier, so therefore they have used this as a strategy. This is a model organism for developing technology. Okay. Now, when you study a pathogen, we can develop novel drug, novel vaccines. So, you might be aware of COVID-19 incidents, pandemic in 2020 onwards. Almost 2.5 years we suffered a lot. How it was eliminated or how it was controlled. How COVID-19, that disease was controlled in India and overall in the globe. Vaccines. Okay. Similarly, you might have aware of people have periodically reported about new strains, gamma, delta variants, something like that, Omicron. Do you remember? At least in newspapers and each and every version killed many people. Do you remember? Yeah, all those things. Where how people could develop vaccines quickly means they studied the entire genome. That is the power of genomics. So they have studied the entire genome of virus and then they developed vaccines using synthesizing particular protein or taking DNA as such, something like that. Each company made different versions of Covishield, Covaxin, something like that. Various types of vaccines were developed by analyzing the genome. They understood the genome of viruses. So therefore, one of the application is developing vaccines or vaccine targets using genomics. So that's why for bacteria like tuberculosis, anthrax, staphylococcus or salmonella, which cause typhoid, something like that. All the genomes are sequenced. People are looking for novel targets and novel therapeutic agents, novel drugs. Some of you might be aware of AMR, antimicrobial resistance. Have you heard about this terminology in newspaper or some science and technology magazine? What people expect is in around another 5 or 10 years, there will be a pandemic of AMR pathogen, antimicrobial resistant pathogens. Meaning, so there are some bacteria like Mycobacterium tuberculosis. Now we control Mycobacterium tuberculosis using some drugs like rifampicin. There are some drugs. Okay. Now people are experiencing or identifying organisms, meaning the tuberculosis pathogens, which is resistant to known antibiotics. Okay. And then people noticed multi-drug resistant pathogens. Meaning, multi-drug means the same bacteria is resistant to multiple type of antibiotics. And then now people are reporting pan-drug resistance. Pan means complete. Okay, all, almost all. Okay, now there are incidents of identifying pathogens like tuberculosis, Mycobacterium tuberculosis. There are some set of pathogens, Staphylococcus aureus, something like that. Pseudomonas aeruginosa. These organisms are resistant to almost all antibiotics. If there are 100 antibiotics in the market, they are resistant to almost 95 to 98 antibiotics. 1 or 2 are functioning. Okay, 1 or 2 are effective. If the organism has developed those 2 antibiotics also, if it is resistant to all 100 antibiotics, what will happen? We will not have any drug for curing the infectious diseases. So therefore, people are working hardly on understanding biology of those pathogens, genes responsible for those resistance mechanism, people always looking for developing newer drugs. At least even it can be costly. Say for example, during COVID-19 treatment itself, people used to use some antibiotics also. That will be costlier. So in some private hospitals, they charged lakhs of rupees for treating one patient, something like that. They use some drugs. At least the infection can be cured using some available drugs. If the organism is completely resistant to all the antibiotics, means you will not have any drug. Okay, then that will kill many people. So therefore now people are giving alarms to every country, every government to develop to take some measures to controlling antimicrobial resistance. So therefore people are looking for novel drug and vaccine targets. Similarly, microorganisms are beneficial in many terms. In agriculture, say for example, people might have talked about organic farming or biofertilizers, something like that. Instead of using fertilizers, use some microorganisms that will be beneficial to the plants. Okay. And comparative genomics and evolution. So there are 1,000 different bacteria are there. By studying genomes of different organisms, one can understand how individual pathogens or individual microorganisms have evolved. Okay, which was the original ancient organism, how other organisms have evolved, all those things, some basic genetics can be understood. And then the another concept, so that is the end. If you remember my title, genes to genomes and metagenomes. So now people talk about metagenomes with respect to microbial genomics, sequence microbes that we can't culture. So that strategy is called as metagenomics. I'll explain in subsequent slides. Yeah, possibly I can skip this. Yeah, this is, I talked about antimicrobial resistance. These are all some of the organisms, pathogens with known antimicrobial resistance. Now, at the end, people are reporting or expecting pan-drug resistance, PDR. Pan-drug means resistant to all. If that is happens, I mean, of course, we cannot survive. And another issue is, so these are all different antibiotics which are available in the market. In each and every hospital, people use only this group of drugs as antibiotics to treat infectious diseases. If you see, from 1960s to 2000, almost 40 years, no new antibiotics were discovered. Not discovered, no new antibiotics were approved because of various reasons, toxicity or poor efficiency, all those things. We are all still using the older drugs or derivatives of older drugs only. So therefore now people are working very hard to discover new drugs. Of course, there are worldwide researches going on in this direction. There are journals like Journal of Antibiotics or something like that. Each and every month, people are reporting some hundreds of drugs, but none of them is not reaching market. Okay, so therefore, genomics can help in multiple ways to understand various targets or developing specific specific drugs. Say for example, a drug which can act on Mycobacterium tuberculosis, a specific drug for Staphylococcus aureus, something like that. For each and every pathogen, a unique target has to be identified, unique drug has to be used. Yeah, this I can possibly, you may not understand. Yeah, how genomics will be powerful in developing this drug is, in genetics, when we study about individual genes, we focus on one gene at a time, and then for characterizing, it will take years, many years. Okay? Whereas if you know the whole genome, that's what we evidenced during COVID-19 cases. Within 6 months, Indian government could develop vaccine, and then it could administer vaccines to almost all people in India. So then only we could survive. Okay. So therefore, using some technologies in biotechnology and bioinformatics, designing drugs. So understand the protein structure, you design new drugs or new vaccine that can be used readily for treating those diseases. So that is the applications of genomics. Yeah, these are all characteristics of new drugs, how people estimate. So it should have effect at lower concentration and it should not have any toxicity. And similarly, metabolism, once you take drug, it has to kill the pathogen and it should be cleared from human system. It should not retain in the system for longer. That will create lots of problems in kidneys and liver. Okay. So therefore, they study all these things. It's called pharmacokinetics or drug metabolism. Not only efficiency, it can kill the pathogen, but at the same time, if causes some issues to human beings, what will happen? Because of taking drug, we will be getting some diseases or problems. So that should be avoided. That's why this will be the overall scenario. Biotech company may identify some 2000 drugs. Okay. At the end, after some 10 years of screening at various level, efficacy study, efficiency study, safety study, toxicity studies, all those things, finally it may reach, one drug out of 2000 may reach market. Can you imagine? A company with thousands of employees working with 2000 drugs, out of which only one is approved by the FDA, that is approval agency in each and every government. So what will happen if this one drug is released in the market? They will charge the money they have spent on all these drugs. Can you imagine? So because a company worked on 2000 drugs, they have given salary to employees and then they have spent monies on toxicity studies, all those things. So multi-crore, multi-million dollars, which they have spent almost in 10 years, 15 years for characterizing all those drugs, will be levied on this particular one drug. So that's why when a new drug is released in the market, that will be very costly, thousands. Okay, have you heard about this? So some drugs will cost about 10,000 or something like that. One vial will cost around 10,000, something like that. There are some drugs. So that is because of the company which releases the drug will charge all of their expenditure which they have spent on other drugs as well. Okay. This I can skip. It's our research. Similarly, vaccine development. Just now I have discussed. Just by analyzing the entire genome, we can develop vaccine within 1 or 2 years. In fact, for COVID-19, within 6 months, we have developed. These are all some research. Yeah, and another application of microbial genomics is to define life in terms of genes. So how to define life in terms of genetics? What is life actually in school days? 3rd standard or 4th standard, you might have taught about living organisms, non-living organisms. Living organisms are given some definitions. What are living organisms? Why it is, we are all called as living organisms. What is the characteristics? Okay, 6 senses. What else? That is for human being. I am talking about overall living organisms. What is life? Growth, breathing for human being. So I am asking in terms of bacteria also. Bacteria has its own life. Anything else? Reproduction. Growth and reproduction. It should be able to grow, meaning feeding on some nutrients, and then it should be able to reproduce, making offsprings. So that is actually called as living organisms. Now, the question in terms of genetics, how many number of genes are needed for the fundamental life? Meaning, the genes needed for growing and reproducing. What is the minimal number of genes essential for the life? So, what is life in genomic terms? The minimal set of essential genes for basic metabolism and growth, and of course reproduction. What is the advantages is, say for example, I talked about genetic engineering, where insulin can be synthesized in E. coli. But E. coli will have some 4,000 genes. It will express all those genes. Some of them might be toxic also. Some toxins, say for example, you are producing an insulin. If some toxin also produced along with insulin means we cannot use those insulin. Are you following? So what people are intended to develop as a synthetic life or designed life is, they wanted to understand what minimal set of genes are needed, and then all other non-essential genes can be deleted, can be removed. Number one. Or with known knowledge on essential genes, can we synthesize a synthetic life just by adding A to these nucleotides, DNA, and then can we create a synthetic genome? The science is called as synthetic biotechnology or synthetic genomics. Just Google it, this terminology, you will get some answers. So what will happen? Just you make a cell with only essential genes, meaning if we provide nutrients, it will grow, divide, and then if you introduce an additional gene, say for example insulin coding genes, what will happen? It will grow, divide, it will secrete insulin. Clear? So that is the ultimate goal in genetic engineering, but that is not yet reached, but people will reach in another decade possibly. So due to want of time I can skip all this. So these are all, in fact people already made some achievements. People have synthesized synthetic genome, people have transformed the whole genome into another bacteria, something like that. All these things have been completed. Yeah, from complete genomes, these red parts can be deleted, only the essential gene, minimal genes can be synthesized. Or we can synthesize from the bottom. You clone one by one and then make these are all some advanced applications. Possibly I can skip. Yeah, overall, these were the scenario before 2013 or 2003, before the genome sequence was available. Now all the genetic principles were converted in terms of genomics. So gene sequencing has now become genome sequencing. Genetic engineering have become genome engineering. Gene editing has become genome editing. Gene shuffling has become genome shuffling, like synthetic genes to synthetic genomes. So initially people designed some individual genes and then they have synthesized chemically and then that can be used for some applications. Now, as I discussed earlier, by understanding the minimal gene set, all those things, people have developed synthetic genomes also. These are all some of the developments in genomic research worldwide. After the Human Genome Project was completed, the international HapMap project, haplotype mapping, meaning they wanted to understand the polymorphism which is responsible for making individual as individual. As I said, na? So people wanted to understand the polymorphism in various groups, various different ethnic groups in various countries, something like that. Then people initiated 1,000 genomes project, sequencing 1,000 individuals across the globe. Now, in fact, each and every country, they have started their own 1,000 genome project. Even in India, people are presently sequencing 1,000 individual genomes from various parts of the country. Yeah, recently there was a project called Earth Biogenome Project. Now they wanted to sequence all living organisms in the planet, in the earth. Okay, in such a way people are generating data. Okay, one side. So what is needed is, people might have talked about data science or artificial intelligence. Remember, So those skills are needed for analyzing these data. So in biology, biotechnology or genomics, so huge amount of data have been generated and it is available free to all. Now the data is with you, with us. We need to analyze the data for making better applications. So what is needed now? What skills are needed? Do you understand biology first? I mean, with respect to my talk I am telling, okay? Biology, genes, genetics, everything. At the same time, the computational skill, bioinformatics or computational biology. So since you are in schools, even if you take biology as a course, you have developed some skills in computer science. Okay, from the fundamental aspects. You learn basic coding or basic languages and then final applications like Python or something like that. In fact, I'm not aware of all those things. But a person with biology, similarly another person may have knowledge in computer science. If a person is having knowledge in biology and application of computer science, then the third person will be given opportunity and then he can get employment everywhere. Are you getting? So both skills are needed. So this is truly applicable for genomic sciences because of the huge amount of data. Can anyone guess what it is? Pardon? Who used this? Yeah, very good. So it's called HMS Beagle, used by Charles Darwin. So he visited Galapagos Island. He saw finches like this. All of them now we call them as Darwinian finches. And then he wrote a book on the origin of species. Okay, and then following. Shall I continue for another 5 minutes? Yeah. Yeah, by analyzing various species and then quantifying individual species in the environment, an ecology or evolution of finches can be studied. So similarly, for bacteria, say for example, these are all two different bacteria. One is a pathogen, another is a beneficial organism. Even by using a sophisticated electron microscope, you cannot differentiate each one from other. Okay? So, people have developed various other molecular tools like, possibly I can skip this. Yeah, what is metagenomics now? So this is the key slide. Later, to classify, people have identified a molecular marker, which we call them as 16S rRNA. In biology, students might be knowing about this. Using this particular gene, we can identify different organisms, and then we can relate this organism, one organism to another organism. So the evolutionary principle can be studied. Okay. So around 1998. So this picture is a soil smear, meaning you take soil and then put it in a microscopic slide and then stain with a stain called DAPI. I mean, there is an expansion here. The stain can penetrate the bacterial cell and stain the DNA. Therefore, each dot represented here is a bacteria. Okay, now there are microscope equipped with some counting principle. Okay, colony counting or just spot counting. We can identify the number of cells present in a soil, for example. Similarly, people used to use, I have skipped, so bacterial culture. They might have shown Petri plate, how to grow bacteria, all those things. By using all those, people cannot culture all those things. So when you see here, the total number of cells per gram of soil was 10 to the power 10. Whereas when they estimate the cells by routine microbiological technique, it was only 10 to the power of 6. What is the difference between 10 to the power of 6 and 10? 4 magnitude difference, 10,000. 1 in 10,000 only could be cultured in your normal microbial plate, Petri plates, for example. So that was a science that called us, that science is called as metagenomics. So genomics, we know, genome of a particular organism. Metagenome means, meta means collection of everything, something like that. So data analysis, metadata analysis, something like that. So metagenomics refers the collective genome, total genome of all living organisms in the environment. So that is called as metagenomics. People note that only 1% of the organisms can be cultured, meaning we have biotechnology department or microbiology department, we have some knowledge in growing bacteria or culturing bacteria. Using all these knowledge available in the world, only 1% of the organisms can be studied, grown, cultured. Rest of the 99% of the organisms cannot be cultured or yet to be cultivated, meaning we do not know how to culture those organisms. Are you getting? Some people used to say that unculturable, but others may argue that you cannot say that unculturable, you do not know how to culture. Clear? So there are 99% of the organisms. So this is a take-home message. 99% of the microorganisms in the earth, in any environment, cannot be cultured, and we did not study those organisms fully. So that was evidenced by various people. Say for example, there was a person who visited Sargasso Sea. He collected deep sea water and then characterized. He could identify millions of new genes. Okay, so that is the power of metagenomics. Possibly I can skip all those. These are all my research. Yeah, these are all research publications. Yeah, then plant microbiome. Genomics or metagenome, as I said, it is a collective genome of an environment. Microbiome means collective genome of all the microorganisms in the particular environment. So plant microbiome means genome of microorganisms which are associated with the plant. Okay, so that is the new concept. So extension of metagenomic principles. If you see the root or rhizospheric regions, there are many bacteria. Without these bacteria, plant cannot survive actually. So what happens in the routine agricultural practices, we use chemical fertilizers and chemical pesticides. They kill many microorganisms. Okay, therefore after some time the soil may become non-fertile. Fertility will be lost. Then what they do is they regenerate the soil by using organic manure. They use some leaves and then vermicompost, cow dung, all those things. By doing all these, they enrich the microbial community. Okay, are you getting? So, yeah, everywhere in organic farming, even the aroma or the flavor of plant or flavor of rice or flavor of tomato, something like that, will be different. Okay, that is due to microorganisms. Say for example, cow rumen. Why cow dung has become a potential fertilizer is the lignocellulosic material, that is plant material, is taken by cow In fact, cow's genome do not code for any enzyme needed for its digestion. Only the microorganisms which are there in the rumen, that is the cow stomach, that is responsible for digesting the food. Similarly, termites, they feed on woody material. Only the microorganisms is playing role. And I can skip this. Yeah, what is with respect to human being? We discussed about SNPs. Only 1% variation is responsible for making individual as individual. Now, people are giving another dimension, like the role of microbiome. Microbiome means the collection of microorganism in the human system, human body, specifically gut microbiome. Say for example, at birth, our gut system will be sterile, meaning almost no microorganisms will be there. Within 2 years of development, based on the environment where the child is brought up, the microbial community will be established within 2 years. So these are all the hot spots like nasal, oral, skin, gastrointestinal, urinogenital. These are the major area where many multiple microorganisms are there. Together, all of them are called as human microbiome. Okay. Yeah, so people have characterized all these. And then one achievement, with this I'll finish. Obesity is a major problem worldwide. So if people have become obese due to various other reasons, say for example, they may become susceptible to developing diabetes, cardiovascular diseases and many other things, hypertension, all those things. So anti-obesity is one of the major market worldwide. So therefore, people wanted to, and this was one of the major research or outcome of research, where people have shown the association between microbiome, that is microorganisms that are there in our gut system, and the obesity. Okay, people identify some way minor or major differences. Later, people, a couple of years later, another paper published in PNAS saying that in obese individuals, their microorganisms or microbiome are efficient in getting energy out of the food that we intake. Are you getting my point? Say for example, some people might be obese, some persons, they may take even very less food based on doctor's advice or other person's advice. They will take only less amount of food, but yet their microorganisms will extract as much energy as possible, and excess energy will be stored as food. Even if they take very less amount of food, they will become obese and obese, unless if we treat them with other drugs or changing the microbiome, all those things. Whereas some other individuals, they may be lean, even if they take heavy food, like one full meals, but they will be lean only. Okay, because of their microbiome. Their microbiome are not efficient in extracting energy because, thereby their food will be going as a waste. Okay, so therefore energy will not be extracted out of your food. So microbiome, that is bacterial population in your gut system, is playing major role in your health. Obesity was demonstrated as one example. If you see, in fact, it was demonstrated in mouse model also. Okay, what happened was, so these are all three different group of mice. They are genetically same, meaning they are from one population. So they are genetically same, 100% same, no difference, no polymorphism, no SNPs. Just they have given fecal microbiota from normal mice, obese mice, underweight mice. Just based on these microbiome composition, they developed as normal, obese or underweight based on these microbial sources. Genetically, all of them are same, but based on the microbiome source, they become different groups, obese or non-obese or underweight. So what is the inference? What is the inference from this experiment? Genetically same means they should be like identical twins. Are you getting? Genetically same means they will look similar or same. Phenotype also should look similar. But just because of the microbiome sources, they become obese or underweight. Meaning, it's a direct evidence for microbiome is playing role in developing obesity. So now people are, people in US and other countries, people are investing huge amount of money on developing microbiome based therapy. Meaning, can we use some combination of microorganisms like probiotics? Probiotics is one example. Instead of taking one probiotic, can we use multiple? Multiple in the sense thousands, not a few, 10 or 100. And the issue is all the thousands cannot be cultured. Do you remember metagenomic principle? So that is the open challenge now. Now people are developing technology for microbiome therapy, but we need to culture all those organisms, then only it can be made as a made as a solution, like a capsule or something like that. Probiotic, one organisms can be grown, lactobacillus or bacillus can be grown and it can be made as a capsule. Microbiome therapy is possible only if you could make technology or if you could understand the science of microorganisms. If you could culture all those organisms, you can develop as a technology. So now microbiome companies are blooming worldwide. Some of you can search microbiome companies. There are thousands of companies are being registered. Most of them are doing research. Because if obesity is controlled, many other things can be, the same principle can be extended for many things, like cancer, diabetes. Say for example, if diabetes is controlled, another 100 different diseases can be controlled. Clear? Yeah. So that is the science. Yeah. Thank you. Thank you for your patience.
Thank you, sir, for your informative speech. Now it's time for queries. Students can clear their queries with the resource person.
Yeah, I'll be happy if you have any questions. Any question? Anyone? Or everything is clear? Thank you. Thank you.
Gratitude is the fairest.
Yeah.
Sir, what challenges exist in ensuring equitable access to genomic medicine across diverse populations?
Can you repeat?
Sir, what challenges exist in ensuring equitable access to genomic medicine across diverse populations nowadays?
What medicine it is?
Genomic medicine.
Generic medicine. Yeah, that involves many things. Because as I said earlier, the same medicine might be discovered by some companies. So they wanted to make money. That will be the one issue. Because they might have spent millions of dollars in multiple compounds. Only one might have been approved. So they will make money out of one drug for everything. So that is the major reasons. Apart from multiple issues are there. Anything else? Yeah.
Sir, can you say again about HAPMAP project?
Yeah, it was international HAPMAP project. So it's called haplotype mapping. In genetics, different types of SNPs, single nucleotide polymorphism, meaning changes in some nucleotide, can be mapped. and then multiple can be mapped. It's an association of certain number, say for example some 5 mutations. Together, how these 5 mutations are represented in multiple persons. Then they will correlate with the susceptibility to particular disease. For example, presence of some haplotype, meaning different mutations with respect to susceptibility to diabetes or cardiovascular disease or cancer or something like that. Together, role of mutations or association of certain mutations with some phenotype is called haplotyping. They wanted to characterize the mutations across the globe, multiple persons. So that is the international HapMap project, haplotype mapping project. Clear? So they wanted to analyze the mutations in multiple individuals across the globe. And then that has to be mapped in the genome structure, chromosome structure, and then how they are arranged, how they are inherited, how it is distributed in various populations, all those things. Yeah. Anything else? Okay.
Thank you, sir.
Thank you.
Gratitude is the fairest blossom which springs from the soul. On behalf of our DST Inspire Science Camp, I express my hearty thanks to our resource person, Dr. J. Rajendran sir, for enlightening us with your presence today. Thank you, sir, for being a part of this memorable occasion.
Now it's time for lunch. Students can go for lunch break and arrive back at 2 o'clock in the auditorium. After lunch, students have photo session, so kindly assemble fast. Thank you.